PRAGYATA 2022 organized by Shri Vaishnav Vidyapeeth Vishwavidyalaya Indore in collaboration with the Institute of Engineers India. The conference theme is Innovative and Sustainable Developments in Electrical and Electronics Engineering. The conference is a two-day event and shall be organized on 27 and 28 of May 2022. The aim of this conference is to bring academicians, scientists, innovators, technocrats, and industry practitioners together to exchange their traditional and modern science ideas to cherish the fruitful outcome of this conference. As we know that the COVID-19 pandemic drove the life online, thus going digital is the new normal. Ladies and gentlemen, we are going to start the first plenary session on IoT and machine learning. We are obliged to have dynamic personality, Dr. Navita Khatri, Director SVITS, Dean Faculty of Engineering and Technology, and Professor, Department of Electrical and Electronics Engineering at Shri Vaishnav Vidyapeeth Vishwavidyalaya as chairperson for today's session. Dr. Gupta received his PhD under the Faculty of Electronics Engineering from DAVV Indore in 2012. He has authored more than 25 international journal papers and many international conferences like IEEE, Springer, etc. He has guided various PhD and MTech projects. His research interest includes nanoelectronics, spintronics, quantum dot cellular automata, embedded system designs, digital circuit designs, and low power VLSI designs. We also have with us Dr. Anand Rajawat, Director SVIIT, Professor in Department of Computer Science Engineering at Shri Vaishnav Vidyapeeth Vishwavidyalaya as co-chair for today's session. He has been engaged in teaching, research, training, and consultancy for the last 20 years. He obtained PhD in the field of software engineering from Devi Ahilya Vishwavidyalaya Indore. Currently, he has been also working as visiting faculty in St. Cloud State University, Minnesota, USA. Besides undertaking consultancy assignments, he has authored more than 102 publications. He has been on the panel of reviewers of several national and international journals. His research interests include software engineering, software re-engineering, big data analytics, and data science. So without taking your much time, I request chair and co-chair of our session to welcome our keynote speakers. Dr. Ajay Agrawal, Professor IIT Jodhpur, Dr. Rajeevan Chandel, Professor NIT Hamirpur, and Dr. Rajesh Kumar, Professor MNIT Jaipur. I request the AV team to please play the welcome video. Thank you. Now let us have the pleasure of listening to the opening remarks of Dr. Namit Gupta. Over to you, sir.
Thank you, Professor Shiraz. Honorable speakers of today's plenary session, Dr. Ajay Agrawal, IIT Jodhpur, Dr. Rajeevan Chandel from NIT Hamirpur, and Dr. Rajesh Kumar from MNIT Jaipur. At the outset, first and the foremost, I would like to welcome you all once again for this today's plenary session on IoT and machine learning. As we know that the theme of this conference is innovative sustainable developments, innovative and sustainable developments in electrical and electronics engineering. In last one decade almost, I must say, the field of engineering in the country as well as in the whole world has seen a tremendous technological change. From as what we saw in late 60s, that changing the world from the bulb type technology to the semiconductor technology, then going to the IC technology and then VLSI and now the nano. In last 10 years, we have seen another paradigm shift in the electrical and electronics engineering, specifically moving more towards the service and IoT based industry from the pure manufacturing industry. So now IoT, machine learning, artificial intelligence, they all play a very vital role in the electrical and electronics engineering also. And as we all know that the coming decade is also going to be to observe and see a more enhanced and a faster version of these technologies being implemented. Nanotechnology or the quantum technology, which is now rapidly becoming a possibility in terms of being implemented practically, is also another field which is coming up very rapidly. And this is the area where there is a lot of research scope for the researchers. So I hope that this session from all the three experts of our today's session, plenary one, will definitely be a guiding light for all the young researchers, academicians, and we all faculty members, so that new areas and avenues of the research can be explored. So once again, I welcome to all of you. And now, without taking much time, I would request the rapporteur, Mr. Professor Shiraz Hussain, to please invite the first speaker. Shiraz, you are mute. Shiraz, you are mute. Please unmute.
Thank you, sir. I am delighted to introduce our first speaker, Dr. Ajay Agrawal, sir. Dr. Ajay Agrawal is a professor at Indian Institute of Technology, Jodhpur. He is a micro and nano device technologist and has keen interest in the development of numerous devices and systems involving transdisciplinary area. He completed his PhD in ME from Plenary in 1995. He was also formerly working as Associate Dean Engineering Sciences in ACSIR. He had served 11 years in CSIR CD as Senior Principal Scientist and Head Technology Business Development Unit and Head MEMS and Microsensors Group. He also worked as Deputy Manager in SCL Chandigarh and Usha India Limited Faridabad in VLSI Fab and Semiconductor Device Development. Dr. Agrawal received CSIR Technology Innovation Award 2020 and Life Fellow Award by IEI, IETE and Meteorology Society of India. He is also senior member of IEEE USA. He also received National Technology Award by Agency of Science, Technology and Research, Singapore. I now request Professor Dr. Ajay Agrawal, sir, to deliver his keynote speech. Over to you, sir.
Thank you very much for the nice introduction. Is my presentation visible?
Yes, sir.
Visible, sir.
Thank you very much for giving me this opportunity to share some of my work and my ideas about the important topic of this PRAGYATA conference, innovative, sustainable developments in electrical electronics engineers. So what we electrical and electronics engineers have a role to play for the sustainability and for the society. So in today's presentation, I'll be covering some of my work at IIT Jodhpur and my previous institution as mentioned by Mr. Siraj at CD Pilani, and also another institution where I worked for almost 10 years is IME Singapore. So some of that work will also be used for this presentation purpose. It is very well mentioned by Dr. Namit also, Dr. Gupta, that machine learning, AI, data analytics, all these are very important aspects. But I'll be touching more on where to generate data and how to generate data. and what is relevant today and what is clear. So I'll be speaking more on that aspect, though we are using AI and machine learning and all these techniques, even IoT for the data communication, but where the data generation needs are there and how these micro nanotechnologies play an important role. And I'll try to show some use cases and some of my research work very briefly. So topic chosen for today is technologies being exploring today or being explored today for better tomorrow. So I'll be touching upon on those technologies. So before I proceed further, I thought let me give a glimpse of my institute, IIT Jodhpur. It's a second generation budding IIT. We started in 2008. Today we are 11 departments and 3 schools. So in this we are indicating 2 schools. So another school of liberal arts has been initiated very recently. It has passed through the Senate. So we have 2 schools here: the School of Management and Entrepreneurship and School of Artificial Intelligence and Data Science. So I am part of a School of AI and Data Science also, and because I use these techniques for my sensors and systems. So that's a brief about the IIT, and we interdisciplinary research. So that's how we work here. So let me go further. So this will be the main agenda of the talk: Sustainable Development Goals, what UN has envisaged, and how we relate these to India. And when we connect it to India, so what are the goals set for our we people in India by the TIFAC and further, and what are the major developments in some of the areas like related to environmental care or healthcare, and some aspect of the nano sensors or micro sensors which I or my team works. So I'll touch upon those aspects also. So we all know this is a very known or very popular picture. So these are the 17 goals, and these were set by the all countries, 190 plus, which are member of UN, and it was thought that these are the 17 goals we should achieve in 15 years. So these are the goals set in 15, and for 15 years, that means up to 2030, these are to be achieved. So this is the list here, but these are all interdisciplinary. So definitely they are interdisciplinary goals, and they need expertise from various departments of science and engineering. What are relevant to we people, electrical and electronics people mainly, since that is the area of discussion today: good health and well-being. Definitely, it looks it is from the biology or medicine side, but we people, we electronics people, have a big role to play in this area. Water, when we say clean water and sanitation, is another area. Affordable and clean energy, definitely this is an important area for we people here. And the another important area we always understand or link to the electrical and electronics people is industry, innovation, and infrastructure. So this also relate to smart cities and what we call innovations are important for any development. So that way these are important goals for us also. Sustainable cities and communities. So this could be more related to smart city project what the government of India has taken for India, and now 100 cities are under that one. Indore is one of the cities which is doing a wonderful job in this particular area. Goal number 13, 14, 15, if you see, these are related to climate actions or life below water or life above water or above land. So these are other important areas where we people also have a part to play as a electrical and electronic. So these are some of the areas which I thought of highlighting here, that these are some important goals where we people can contribute. But yes, we will not be working in isolation. We'll be working with many other field of sciences and experts in different areas. Now let's come to TIFAC. TIFAC is a body in India and which has given a vision statement in 2015, and these have 12 items here, so which are listed here. And this document has come for a vision of 20 years. So the earlier sustainable development goals were for 15 years, which are for all the countries of the world. We have decided to adopt that one, but this type of vision document has come for India. Important points. So these were 12 points, and this is 20-year goals. So here, if you see the points I have put in red, they are the same points which were there in the international or the UN Sustainable Development Goals. And definitely, these are the points where we have a role to play. Here, if we see energy, healthcare, and all these things are important, and speedy mobility is another part. Safety and security also we have considered under these points. So these are the points important for India. We have passed, or we have seen a very troublesome period in last 2.5 years. So in 2020 March, this pandemic broke out, and soon after that, TIFAC came with a white paper. And among all these 5 points were prioritized in May 2020. So if you see in the priority list, number 1 has come the medical, and though it was there earlier also, but it has become the number 1 requirement of the country. And so far, country has done wonderful in this particular area. Other second point, if you see machinery and manufacturing, so there has been a great emphasis on manufacturing, make in India, and information technology has been always, and because of this only we could survive in last 2 years. We could run our schools, colleges, and we could communicate, we could buy things, we could do the payments. Everything was because of ICT technology. So this has become a major electronic important aspect for we engineers. Number 4 is now coming as the separate electronics, and we are seeing that electronics, the mission for electronics, manufacturing of electronic goods in India now government is pushing. So this is because of this important point which has come in the priority list now. And of course, agriculture and food we cannot deny, which is another important area, and it cannot be neglected. So these are the 5 major areas where government is emphasizing, and in all these areas we have a role to play. I can say in all these areas 100% electrical electronics technologies are required and are being used also. So that's a relevant thing. Let's see 2 important areas, healthcare and environmental care, where what kind of innovations we have seen worldwide and where we can work on in the coming days. So if you see worldwide technology innovations in the environmental sector, these are the points. So electrical transport, public electric transport has been number 1 very recently as an innovation or area where we want to work and people are working on. So it's not only electric transport for the people or for the commutation purpose. Electric trucks are now being used for the transportation of the goods. So that has become a second important one. And when we are using long-term transport, high power requirements, we are looking for cheap energy resources, storage options. So this has become another big area for energy storage for environmental point of view. And we are also looking for long-term storage. because the energy stored should last for hours together. Otherwise, these vehicles will be charging again and again, which is not a practical solution. So these are all related to, first four are related to the EV, so electric vehicles for commutation purpose, trucks for transportation of the goods, and related to the energy storage and long-term storage. So cheap and long-term storage. So both are keywords. Next important aspect is plastic recycling. We have been generating a huge amount of plastic, or different kind of plastics, and only 16% of this plastic is recycled. So which is generating a big alarm for our environmental conservation. So this is considered as number 5, and a lot of new technologies now being worked out how to use this plastic for various different applications. LED lighting efficiency improvement is another important area, and in our country also we have seen that a very good development has happened in this area, and further development required in this area so that we can provide lighting at all the required places at low power consumption basically. Accessible solar power is another big area, and our country is doing quite good job. And places where the sunlight is for a good amount of time, and definitely this should be harnessed more and more, and this is also being worked out in different area, but still some more need to be done in this particular area. Another important point from the environmental point of view is carbon capture and storage. So as we are using more vehicles, we are using different, we are developing. Definitely the carbon in the environment is increasing because of carbon dioxide, carbon monoxide as a byproduct of a lot of different machine vehicles and other things. That now technology is being worked out how to capture it and store it underground so that we can make our environment clean. So this is another emerging area, and good amount of research being done in this particular area also. Hydrogen as an energy is another important area. So as a part of energy, when we see, so how easily, how affordably, how safely we can use hydrogen for energy purpose and for all kind of energy purpose. So these are the important areas listed, or technological innovations which has happened very recently, and still people are using, exploiting them for different applications to make life or environmental clean. Now let's see top 10 healthcare innovations worldwide, and if you see next generation sequencing is one of the things where not much for we electronics people, but this is the number one that the sequencing has come up, which helps in different kind of therapies, which is a targeted therapy or personalized therapies. But let's leave it for others to do more on it. 3D printed devices, which is in our domain, and it has revolutionized many aspects of treatments and customized treatment, and at low cost customized treatment for basically the, say, like the Jaipur foot or many other these prosthetic parts can be developed, and low cost and low weight can be developed using these 3D printed. And this is just one example I mentioned, but 3D printed devices now being used for many applications, and that has become a revolutionary technique, and a lot of different kind of materials being used for this purpose. It's not polymer, now metals are also used. You might have heard like 3D printed houses are also made using these techniques now. Immunotherapy is another area. So this is different kind of treatment where instead of traditional chemotherapy, immunotherapy is taken, and it is more effective and it has less effects. Let's not talk much on this one. Artificial intelligence in healthcare is playing a big role. And mainly if we see in data analytics, and when we are having a huge amount of data points, and it is difficult to just mine out some meaningful data from these huge data points. AI based algorithms, AI techniques can help us to figure out what meaningful information do exist in these data points, where a lot of noise might be there, a lot of interfering data points are there. So artificial intelligence is playing an important role in medical domain. And this is all because of electronics people, with AI people working with people that like doctors or people working in the diagnostics. When we talk of healthcare, the important area is point of care diagnostics. So in last 2.5 years, now we understand point of care is a huge requirement. We want all the diagnostics to be done at our home or in the hospital. We don't want to travel, or there are many scenarios. So I'll discuss, I have highlighted this one, so I'll slightly discuss more on what are the scenarios for point of care diagnostics and how different electronic aspects can come in for different kind of application areas there. And some other aspects are virtual reality. So AR, VR related technologies are now helping in a lot of diagnostics and a lot of treatment related aspects. I'm not going the details of different aspects. Leveraging on social media and improving patients' experience, which is another area which is being highlighted as a worldwide important innovation for the healthcare. Biosensors and trackers, we understand that they are playing an important role, and to put wearable devices on the body to track a person when this person is in quarantine, or a person need to be in say home treatment. So you put a lot of devices and want to monitor that conditions from the remote. So there are a lot of these needs are there, monitoring from remote and tracking and other things. So these electronic gadgets in different formats like IoT and AI are playing important role. And convenient health, as we know that we all are looking for convenience and low cost. So anything coming in this aspect is considered important, and a lot of work being done. And telehealth, we have seen again in the last 2.5 years how important is telehealth, and how sitting in a room or the quarantine people quarantine at home in isolated areas, they are able to talk to their doctors and taking advice, keeping their well-being. So these technologies have played an important role. And let's move on further. So as I mentioned, let's look at the diagnostic aspects. When we say point of care diagnostics, these are some of the gadgets come to our mind. We know that glucose, blood glucose measurement, or some urine test or pregnancy test. And there are so many tests which are very common, and many of these are being used at home or in a primary care centers. We go there, they test it, and immediately we know the answer. That helps. But how we describe them, they are of 5 different classes. And we electronics people have slightly different role to play in all these 5. So I am looking from the electronics point of view, these 5 different classes of point of care. The first one is home assessment. So like we do for blood glucose measurement, and blood glucose assessment we do, and if it is more than we talk to doctor. So we are doing assessment. We have been told that you have to check a parameter and it has to be in particular range. If it moves out of that range, then consult a doctor or take a medicine. Other thing is community based. That means we go to a community like a school, we test, scan all the students for some particular condition, and if we suspect some of the students for that condition, then we refer to a doctor. So these are also handled by just parametric, the paramedics or ASHA workers. So these are not doctors who are handling. You go to a community and you scan them for a disease, and if a few patients are found suspected for a disease like TB or for dengue or other conditions, then they are being referred to. This is more becoming more important. So testing on the doctor's table. Doctor, before prescribing a medicine, he need he need to do some analysis. So it's those days are gone. Just BP or temperature is good enough. He need to do some blood testing. So take a drop of blood and test and get immediate answers, or some urine test immediately there on the spot. And these things are common in many developed countries. So any doctor is only prescribing after doing some initial test on the table. The the fourth stage is peripheral labs, which is very common in India. So you have been diagnosed for some of the condition, you want to get it checked, so you go to a laboratory, but you want to get it tested there. But these devices, the point of use, so we want these solutions to be quickly. So these systems, the systems what we are making, they lie in these peripheral labs, and they do the testing and try to give you answer much faster today because of some new technologies coming up. And the final and the fifth stage where these point of care are used in hospitals, in mainly ICUs, where the patients are lying and their tests need to be done very frequently, and whenever the doctor comes on the routine checking, so they need to test some conditions on the spot there. So these point of care devices do help doctor to take a decision while they are on the round, because the patients cannot be transferred to the lab even for those tests, and the time required for those analysis should be very less. So all these systems have some biosensors, some elements inside, but what all it is something like this. So this is a bit complicated picture looking here, but don't worry, I'll quickly summarize it in a simple way. So let's see from the leftmost vertical, samples. So these are the samples we test. So for human being, cells we know that we have been testing our cell from our throat and for COVID testing. So cells, so many times we take a cell sample. So these cells need to be tested, and we have markers in this. These are quite common. The blood is there, urine or saliva. So these are the samples from the human being journal. There are many other samples also. Tissues are also tested for cancer and other applications also, because they have markers in the tissues. Food samples and environmental samples are similar, so they also need a lot of testing today. And I'll not touch upon much on this, but these are the samples, and they are also being tested in a similar way. Now, coming to the electronics people, we are making these devices. These are the nano or micro technology based devices which have better selectivity or sensitivity for some of the markers. To make them more sensitive, we are using nanotechnologies. So, like FET, this is a field effect transistor. So, any charge comes, we see a change in the channel. Now, if it is very, very sensitive, a single molecule coming in the contact should be able to detect. So, this is what we are doing with these nanosensors. And but why a selective charge will come? Because there are so many molecules here, all will be having a charge. And please mind, 90% of the molecules have some kind of charge. So to make it selective, we want these bioreceptors. So we functionalize these sensor surfaces like these with these bioreceptors, and these bioreceptors only attach the target molecule. So this is being done by biochemistry. So chemistry and biology people have an important role to play. And the markers here are told by the doctors only. They know, biochemists or the doctors, which are the markers for that disease. So accordingly, they can make receptors. We can attach receptors on our sensors. And when this charge comes on this, a single charge or a few charges, we will be able to detect. Now, if we are detecting very few charges or few molecules, the signal is very low. So it is close to the noise in the system. So that's why amplification is required. So electronic people stop. Signal processing is required. So because what was the signal before and after? So a lot of processing is required. And after processing, you get some data. So data analytics, display, presentation, data to be transferred to someone, IoT is required. So this is purely electronics and different field of electronics. Circuits, signal processing, signal amplification, data analytics, and further. Fine. So this is how we work. So highly interdisciplinary, but we have an important role. I have been working on some other cases. I'll show you some cases quickly. And typically, these are the 4 different properties which we use in our sensors. Potentiometric means we are leveraging on the charge of the target molecule. Amperometric, where the target molecule react on my sensor surface specifically and give some electric current, and I am recording that current. Optical, we see some, there are various versions here. Fluorescence is there, fluorescence is there, or interference or absorption, etc. But change in the color and other things, you put a sample, you see a red line, a blue line, a green line, that gives you a very simple output. Most of the time, there is no quantification here, but many times quantification is not required. So yes, no answer is good. And so optical measurements are there. And 4th class is acoustic. You have a sensor. When specifically a molecule binds there, we see a frequency change of that. So we are recording the frequency of that crystal there. So piezoelectric crystal is there, and we record the change because of specific binding. And these are some of the 2 cartoons what we are doing. So you have a system here, and this is a kind of chip. You put your sample here, you put it inside. So this is optical. So something reaction happening, you put inside, there is a color reader, and immediately you can have a color here or some digital numbers can come. You may just see it and that is enough, or you can transmit to your mobile or to doctor's mobile. So IoT is playing an important role there. You do testing at home, but your doctor knows what you are doing at home. So he can give you a suggestion based on what has happened. Similarly, if it is electrical, so you have an electrical change here and it can be communicated accordingly. Let's see some of the platform devices which I have been working. I can have some another 5 to 10 minutes.
Sure, sir. No
Yes, sir. Sure, sure.
Okay, thank you. So these are some of the platform devices which are working on the charge base. So these are all from my group, what I am putting here. So we have been working on these devices. These are all charge-based devices. So like ion sensitive field effect transistor. So this is called ISFET also. So you have a very sensitive device here. You do a surface functionalization, and when a specific charge comes, you can see electrical shift. And these are the nanowire based devices, which are one of the most sensitive device among these. And even few molecules coming on these nanowires, you can detect the change. And multiplexing is possible here. Multiplexing, I'll show more on this one, what does this mean. So these are some of the 5 different kind of field effect based sensors or the platform devices. Depending on what kind of surface modification we do, we can use them for different kind of molecule detection. These are some of the microfluidic devices. So microfluidics, as I mentioned, is important. You have fluids in microliters now. So when your sample quantity is less, so like just a drop of blood, few drops of blood, or few drops of some other samples from our body part, these gadgets are very, very important. And these are some of the devices like lab on chip. This is a patented device from our lab. And what we do, we separate the cells, RBC or WBC of a blood sample, and just we want a microliter of blood, and we can do counting of the blood cells and the plasma is separated and multiple things. And this is for the viscosity measurement of our body fluids, and viscosity is another important aspect which gives a lot of indication. And you have to just put a drop here, it flows and give you in real time what is the viscosity. So similarly, these are the other devices. The other devices which are being used based on micro nanotechnologies are some of these like gas sensors. So this is a small chip, 2 mm by 2 mm typically. So this is a zoomed image, and this is a sensing material here. If any gas comes, like our breath or body smell or any gas in the environment, so these are very sensitive and can. So I'll show some more details on some of these devices, not all. This is another device which is search based. So this has a capability to detect single molecule. Single molecule, I am saying, if you have a single molecule of a type, possibly we can detect using this type of chip. And I'll show some of them. And pressure sensor and ultrasonic transducers, as I mentioned, they are also being used for various diagnostic applications. So just a couple of slides on some of these platforms showing some results. So like environmental monitoring, when we say these are some of the gases of interest. And we have seen now and then in the newspaper, in the news, that there have been leaks, and these are creating a lot of hazards in our environment. So it's important to detect them at an early stage. But why they are not detected? Because the systems are very costly. They are not with all the workers or in all the workshops. So can we make it a smaller, cheaper one, and they are connected through IoT to a supervisor, to the control room, so that a proper action can be taken if there is a leakage. So we have worked in this area, and I'll show you some systems what we have realized they are useful for this type of applications. Our breath also has many of these gases I indicated in this table, and which are signature for deadly disease like the cancer, diabetes, asthma, kidney functions, dysfunctions. So if you can detect these smells in our breath, that's a clear indication of the person is affected by that particular condition. Or it could be useful for monitoring your health. Say person is diabetic, so the acetone smell comes. It's a sweet smell. So breath is very sweet, but if you control it, your diabetes in control, the smell will go. So by just monitoring your breath without pricking, just monitor it, and you know that are you in control or you are going out of control. So that kind of application. So this is a chip. We mount it on a header, and this becomes like this. So these are available in the market also, but not that selective. So selectivity comes from this material what we are putting there. And then there are systems like this. How they work? They are all chemi-registers. This is of interest to some students if they are here. So you expose a register to oxidizing or reducing gas. If it is oxidizing, resistance increases. If it is reducing, resistance decreases. You switch it off, it comes back. You give the lesser concentration, the change is less. Further reduce the concentration, the effect is less. So that way, what we are looking is the changes and what kind of changes percentage, and they respond as a function of temperature. So that's why there is a heater also, a micro heater here, and you can see this is temperature and this is sensitivity. So for this blue curve, the maximum sensitivity is achieved at this temperature. So if you can maintain this temperature, you make this sensitive. But many times these materials respond to many gases. So that's a confusion there. What gas it is responding to. So you have to look for some kind of multiplex materials, two materials, three materials together in a combination, or you scan and see the pattern, how it is responding, and based on data analytics, you can distinguish the gases. And we have done it for many cases using data analytics. You can distinguish multiple gases in a system using cheap sensors. And this type of handheld system like our mobile phone, with all kind of IoT-enabled features or control features. These can be used for many applications. Nanowires, as I mentioned, they can be used for multiplexing. Means, say if your sample is there, say blood sample, if you see the viral infections, there are 36 different kind of viral infections. So how do we detect 36 different kind of which infection it is? Normally what happens when we go for a viral infection, we are given a medicine which covers a set of virus. So it works on 5-6 different kind of virus. If it works, it's fine. If it doesn't work, doctor prescribes another antivirus, which works on the second class of antibiotics. But doctor do not know what it is actually. So it is not a it's a precision medicine or exact medicine. So if you have these kind of things, that means I have different kind of sensors which are attaching. So these dots are different kind of molecules. So red will attach to red only, blue will to blue, green to green. So that way we can test multiple molecules in a sample in a one go. This is called multiplex. So this is what we have been doing. So these are the actual pictures of sensors we have made. These are the nanowires. So these are same images, so you can see. But there are hundreds of such sensors, and each one is having a separate electrical contact. Dimensions here are for these wires, and at the bottom I am giving some references of my papers there. Now, simply, this is a cross-section cartoon of this nanowire, a single wire sensor. So if you have a charge, say like you bring some acid, so you have a HINs floating. So they will respond. If I am increasing the HIN, so that the red dots means the more pH, more acidic, the change is more. But if I can bind these charges using silination, these changes can multiply very much. So 2 to 3 times amplification happens. This becomes important when the charges are very few in the sample. These are very strong solutions, large number of charges are there. That's why without binding also they are responding. But if they are very few, you have to design it so that they can bind on the surface and we can see the effect. These are some of the examples. I will not go in the details related to the DNA, and by what we have done is specifically we have moved the target DNA piece by 2 nanometers. And if I was able to move 2 nanometer, I could see the drop in the output. So this was the output with the fully hybridization happening from the closest point, and as I'm moving 2 nanometers away, the output is reducing systematically. So the binding molecule configuration also matters for these type of sensitive applications. This is another example from the DNA testing. I'll not go in the details. If somebody has interest, we can discuss later. This is for very low concentration detection of cardiac biomarkers. So these float in our blood, and for the early detection of heart condition or many other, when the concentration of these markers is in say femtogram milliliter, which is extremely low concentration, we could detect. So very early stage we can detect these markers and treatment can be done. So I'm not going in the details of what these have been done, and these are some cell cultured on these type of sensors, and then you expose these cell for different chemicals, and how the cell respond, real-time signatures can be captured, and these are giving information that how a particular drug respond to response comes from different kind of cell. So this is another work we have been doing. So this is another kind of cell, and this is from the organs also. So this is the heart of a mice, 3-day-old mice. We have done a surgery, and from the surface we have recorded the ECG. And this is from by putting a micro electrode in the heart. So they are meaningful. Idea is these are very sensitive sensors. They can work in contact with our body and can be useful for a lot of applications. And this is last example of this particular device where you have a blood to answer, because there is a lot of processing need to be done. This is again a patented device what we made. So you put a drop of blood, it goes, all processing happens, and it comes here, and you can detect the answer, or you can detect the analytes of your interest or the biomarkers within. So this is a kind of prototype. This is an optical picture of this one. This sensor I mentioned, a single molecule, can be detected, and it has an array of gaps which are in the range of 20 to 30 nanometers, and it has a special coating of silver, gold. These are good for trace level molecule detection for the biomarker, explosive, warfare, and other things. So we are using it for many applications at this moment. This particular example, what I am showing here, is for breast cancer detection on the bedside. So doctor wants to check if the tissue removed from the patient is clean or still having cancerous tissue there or cell there. So on the bedside, if he knows, he can stop the surgery if everything is clean. Otherwise, he has to remove some more tissue. Because if a single cell is left there, it will again grow. So that is a crucial problem given to us from Tata Memorial Hospital, and then we were talking about this. This is a COVID detection using the same thing, using our saliva, and it's an instant solution. So we have done this is actual testing done of saliva from 9 patients. This happened in phase 1 of this COVID, when the first phase of the corona came, and we developed this one, and we tested in a hospital the saliva of 9 patients, and all were positively characterized using our system. This is the chip I have already mentioned. I will not go further, but it is useful for many applications. These are different kind of microelectrodes we have been preparing for electrical sensing, and if the current generates in the system, they can be very precisely measured using different configuration, 2 electrodes, 3 electrodes, or multi-electrode systems. And this is another patented thing. So which separates WBC, RBC, and this one. And let me play this if it's possible. So you can see how the particles are moving in this channel, and they separate out. So here you can see that red blood cells are separating in this one. So how much channel is filled? By just viewing it, I can estimate what is the count of this one. And WBC remains in the smaller channels here, and the plasma comes to this one. So that's a very quick estimation of RBC, WBC, and plasma. And this is very common type of testing for many applications. In fact, this quantity can be related to hemoglobin also of a patient in a remote, if you want to do. So this is a quick analysis, and more sophisticated gadget is required. So that's all from my side. And in a conclusion slide, with innovative ideas, healthcare, environmental care sector offers a huge opportunity for electrical and electronics people for its sustainability, basically, and to realize various point of care or early diagnostic solutions. Different expertise in engineering sciences, mainly electronics and electrical, what we are talking today, like micro nanotechnologies, electrical circuit or electronic circuit, signal processing, data analytics, and instrumentation. So all are important, and they are playing an important role. And various platforms which I discussed, one has to wisely choose based on what marker we are looking on and what kind of concentration we want to detect. Because some are very sensitive and some are not that sensitive. And if the marker concentration is not very low, don't go for very sensitive device. Otherwise, you will have a lot of problems related to the noise. This is a link where all my publications and my do publications do appear. So Google Scholar, you can scan and you can find all my papers for the reference purpose. I would like to acknowledge all my colleagues and students who have worked with me or are working with me at IIT Jodhpur, and who have worked with me earlier at the CERI Pilani and IME Singapore. Thank you very much. I am open for any question or comment.
Thank you, sir. It was wonderful listening to you. I request if there are any questions, then please write in the chat box so that we can take them later on. Now I would request the moderator, Professor Shiraz Hussain, to please introduce our second speaker today.
Thank you. We also have among us Dr. Rajesh Chandel as our second speaker. Professor Rajesh Chandel was awarded PhD degree from Indian Institute of Technology, IIT Roorkee, India, under QIP scheme of Government of India in 2005. She received MTech degree in Integrated Electronics and Circuits from IIT Delhi, India in 1997. She received BE degree in Electronics and Communication Engineering from TIET Thapar University, Patiala in 1990. She is a double gold medalist of Himachal Pradesh University, Shimla, India in pre-university and pre-engineering in 1985 and 1986 respectively. She joined the Department of Electronics and Communication Engineering, NIT Hamirpur, as a lecturer in August 1990, where presently she is working as a professor and has been the head of department for 10 years. Dr. Chandel has been Dean Research and Consultancy and Dean Academic NIT Hamirpur. Her research interests are low power VLSI design, interconnect design, and others. She has been volunteering from several years in Narayan Seva Sansthan, an NGO committed to help and uplift the life of underprivileged, physically challenged humans. I now request Professor Dr. Rajesh Chandel, ma'am, to deliver her keynote speech. Over to you, ma'am.
Ma'am, you are mute. You are mute.
Thank you so much, Shiraz. Am I audible?
Yes,
yeah, you are audible, ma'am.
Thank you so much. So at the outset, I would like to express my gratitude to the previous speaker and expert. It was a pleasure listening to Professor Agrawal. I would like to take this opportunity to thank Professor Namit Gupta and Professor Anand Rajawat, who are chairs for this session, and the whole organizing team of PRAGYATA 2022, a very beautiful name coined for this international conference. I must appreciate. I also would like to put on record the conversation and emails we have had with Dr. Navita, then Professor Anjali, Dr. Swapnil, and Shiraz. Thank you so much for associating me also with your important international event. And the theme chosen, that is your innovative and sustainable development in Tripoli, is very precise and requirement of the day, actually, which has been very beautifully summed up by the previous speaker. I would also like to pay my compliments and greetings to all the delegates and the participants of this conference. And we may now start with the talk, which is on VLSI signal processing and how what are its various applications and how those things are related to sustainable development, actually. So let me go to the slideshow mode. Is it fairly visible?
Yeah, ma'am.
visible.
Okay. Before actually talking about anything related to VLSI or sustainable development, it is a very beautiful year, 2022, which actually takes us to 7.5 decades of solid state transistor. So I would like to begin my talk from here, since many research scholars and delegates would also be associated with this conference. Then we would talk about VLSI signal processing, and then the applications and conclusions. So as such, we all are aware that what an integrated circuit is, what a very large scale integrated circuit is, wherein we have now not millions but billions of transistors on a single chip. And presently, when we talk about the silicon era, CMOS technology has sophisticated to very high scale, and it has nearly reached its limits of silicon, and that has also led, since that has led to high chip complexity, a large number of components per chip, so that has actually moved to a power constrained era, and therefore power dissipations and the delays associated with these devices become very important. Another aspects of integrated circuits is that both the logic gates or the devices, you may say, and the wiring which is connecting them, they are inseparable, and therefore the IC performance becomes totally dependent not only on the devices. Howsoever improvement in the device performance may be by various variants in FETs, various variants in nano devices, unless and until we touch interconnects, we will not get the full advantage of this particular technology. And hence, both these become equally important research areas and a part of VLSI. And therefore, power, quality issues, and signal processing is the requirement when we talk about these. So let us firstly talk about something about solid state transistors, which began in 1947, and in 2022 it is 75th year of the innovations in this transistor. And the first transistor, which was a solid state transistor, was demonstrated actually in 1947 at Bell Labs. And the three individuals, that is Shockley, Bardeen, and Breton, they are credited with this invention. And then thereafter came Robert Norton Noyes, and he is credited with the realization of the first monolithic integrated circuit or a microchip. Then you see, he also gave, or he realized, mass fabrication or high volume manufacturing of integrated circuits, and it was in the following years, 1959. Along with his name also is a very important name associated, Jack S. C. Kilby, who was at Texas Instruments, and he is also associated with the realization of the integrated circuit, and he was awarded Nobel Prize in Physics in 2000. He passed away in 2005 actually, but his contribution is immense. Then we can see the first planar bipolar transistor, which we have all used in our laboratories, which is seen here as by Fairchild. And then first MOS transistor amplifier was demonstrated in 1960 by Atala and Khan, and these also can be, the pictures can be seen of his amplifier. And as you go ahead, in 1965, Gordon Moore, who was an American businessman, engineer, and co-founder and chairman emeritus of Intel Corporation and also Fairchild, he gave the famous Moore's law. It is an observation that he made regarding the increase in the number of transistors on a chip. Though in 65 he said that it would double every year, then he again saw this for a decade, and in 75 he reproposed that no, it would double every 18 months, or rather 1 year, you can say. So Moore's law is actually, it is an observation, a projection of the trends. It is not a law of physics. it is an empirical relationship, but it has been a guiding and force for the planners and for the R&D targets in industry. So it has been there since long. Then we see so many variants of BJTs coming up: lateral PNP, substrate PNP, vertical integrated PNP, BJT transistors. Simultaneously, planar MOSFETs, so many variants have come up to deal with so many different structures have come up, and we will see in a minute why these structures became important or required. Simultaneously, on the device side, you see we started with planar FETs, then you have FinFETs, then horizontal nanowire, vertical FETs, complementary FETs, and stacked FETs. These are how the changes have taken place in the architecture of the FinFETs, field effect transistors. You can further see in IRDS, that is International Roadmap to Devices and Systems. Firstly, earlier we had ITRS, now more important is IRDS. In that you can see all these, where silicon FinFET was already given in 11, and then you have silicon germanium FinFETs coming up, vertical gate all around FinFETs, then your vertical tunnel FETs, lateral gate all around FETs. So each one has some improved performance actually, and that is why they are being researched and worked upon and being used. So let us see this particular important trend. So you see, earlier USA, which was having a very huge share in the chip manufacturing, has decreased significantly, whereas you can see Japan, that is here, and then yellow is South Korea, light blue is Taiwan, and China. Their share has dramatically increased, and by 2030 it is assumed that they will be the leaders, and particularly you can see the China's contribution. So in this regard, India is also making a strong beginning by the various initiatives of our government, our Prime Minister and Ministry of Electronics and Information Technology, MIT, who are giving so many projects in form of chip to system design and chip to startup design for various institutes, all IITs, NITs, and many other institutes, which your institute too can be benefited from. So we are making a start through the startups, which will definitely help in sustainable development in the long way in the time to come. So once again, the famous Moore's law, which shows the dominance of silicon in industry whatsoever till the present era, and it is because of this technology that we have been able to give very sophisticated mobiles, very sophisticated systems, machines, that is your PCs and desktops, laptops, and palm tops. And it is because of this technology that we have been able to accommodate so many components per chip, which has been possible. And salutes to Moore, who was so visionary person and who could imagine that this would continue for a long time, and it has sustained even today. So these are all from ITRS, and we have seen that how this has been possible because technology features have reduced and continuously. Then gate lengths have reduced for the MOS devices. Simultaneously, supply voltages have reduced. The number of components or transistors per die, you can see how they have enhanced in number of billions of transistors per die to accommodate or to connect such a huge number of components on a die, you cannot do a wiring on a single level. And therefore, multiple levels of wirings have been used. And when I teach my students in the lab, we are not able to go beyond metal level 2 and 3. So just imagine the complexity with which the people in industry have to work when they deal with 15 number of wiring levels or interconnects and so on. So in all this, the power dissipation has been contained. So that means even if number of components have increased, number of wiring levels have increased, so that means we are simultaneously working on other aspects which contain the power dissipation in terms of low power design techniques which are embedded simultaneously. So simultaneously, you can see that memory's capacities have enhanced significantly. And all this has been because of the miniaturization of the feature size from micrometer to deep submicron to nanometer regimes today. So when Professor Agrawal says that it is a FinFET or a ISFET, in that particular in nano regime, it is all because of the feasibility of the technology that we have been able to reduce the dimensions of the MOSFETs. So miniaturization or reduction in size of the devices adds a lot of advantages in terms of their current carrying capabilities or lesser gate capacitances, faster processing or higher chip complexity, but it also leads to so many narrow and short channel effects in the devices like body bias effect or channel length modulation, mobility degradation, velocity saturation, charge sharing, or DIBL, drain induced barrier lowering, and sub-threshold current, and so many other things. So these are the things, actually, these non-ideal effects also lead to many research avenues when we talk about VLSI devices typically, because we have to overcome these things at the device level so that those FETs or those devices are made usable in the circuits. So this particular slide also is very important, which shows the typical dimensions in nanometers, number of devices, say typically 10 raised to power 9, say, and you can see this Xilinx chip contributions, that green area is 65% interconnects, dark blue is clock, which is 21%, IOs are 9%, and CLB, that is configurable logic block, which is the actually the devices, you can say, that has only 5% part in the whole chip. So you can well imagine that the devices and the interconnects, I have made the word green and blue to depict that the major research which is required in any area is more prominently required in interconnects or wiring rather than devices, because devices have reached a very significant sophistication level, and simultaneously the other era also requires that. So now you see, when we talk about VLSI design, three things, that is delay, power dissipation, and noise. And fourth one, you can say, is the effect of process, temperature, and voltage variations. These become very, very important. These come in the devices or in the circuits formed from those devices because of their inherent parasitics. Parasitics will be in terms of resistances, capacitances, which are associated with these devices, and they bring they lead to actually limiting factor, either in terms of frequency usage, or if it is high power dissipation, then cooling arrangements, then if it is higher leakage, then your battery life becomes is actually becomes a problem. And likewise, if noise and crosstalk and various process variations, temperature variations take place, then timing failures can occur in the devices, which make the actually the whole circuit non-functional. And therefore you have to deal with all these things simultaneously because of the continuous demand for these gadgets, more electronics, more, so as to make the human life more comfortable. More comfort means more devices, more gadgets, which will actually lead to different problems which need to be overcome actually. Be it effort on cooling, be it the operational cost, be it the batteries. So see, each part becomes a research area in itself. You have to deal with all of them. So let me touch just the power dissipation part. When we talk about MOS devices, power dissipations are the power dissipation is divided in three parts: dynamic, static, and short circuit power dissipation. So you can see that power will always have a direct variation with supply voltage, or it will have a quadratic variation or cubic variation. Then it will also depend upon the load capacitance, which we have shown here. Then it will also depend upon the switching activity. It will depend upon the frequency of the operating signal. It will also depend upon the reverse saturation currents and sub-threshold current in the device. Likewise, the transistor dimensions, K is the transconductance parameter, that then frequency again, and the rise and the fall time of the signals, as well as the threshold voltage. So see, all the parameters, be either they are of the devices or they are related to the signal which is being used, all of them actually affect some or the other part. And if you have to contain this, then you have to work on each parameter. For example, clock gating or using sleep mode can contain the switching activity. Likewise, if we use smaller transistors, smaller wirings, that can lead to smaller capacitances, but it will have impact on the other performance parameters. Then supply voltage, you can use the lowest supply voltage, but that will have a inverse impact on the other performance parameters. So we cannot do that also. We cannot use the lowest suitable frequency because we want maximum speed of our devices. We want our mobiles to be fast. We want our systems to be fast. So how can we use lowest suitable frequency? So see, some of these things have to be taken up one by one. For example, in ratioed circuits and low VT devices can contain static power. Likewise, small dimension devices or fast signals, steep signals, then low voltages, frequencies, and VTs. They can be useful in some categories, but for majority of the circuits which are developed are optimally designed, where we cannot go in for the lowest thing in one category for power. So this is because so many parasitics are associated with the MOS devices, and if parasitics in form of capacitances are if you take them into consideration, they will impact not only the load capacitance, but load capacitance which is impacting the power dissipation to a large extent will not be a constant actually. It itself is a variant of the MOS device, MOS dimensions, and the fan outs which are being used, the interconnect which is being used to connect the main circuit and the fan out. So everything has interrelation which needs to be taken care of when we are processing the signals and designing the circuits. Because on one hand you have power, on the other hand you have delay. And I will just go to the last this equation, which shows that delay again is a function of the load capacitance. Again, similar parameters, supply voltage, conductor, and this dimension of the transistor. So where earlier we were saying that the dimension should be small so that the power could be low, here dimensions have to be large so that the delay could be less. So that they are so contradictory in behavior and nature, that we have to design the circuits optimally so that the delay constraints are also met, power constraints are also met, so as to get an optimally designed circuit. So in order to control the delay, you have similar type of parameters, but you will see that mostly they are inverse to what we have been what are the requirements for the power, and therefore optimally you have to design them. If we see the interconnects, if we see the global interconnects, basically the large interconnects means which will traverse the whole chip, which will supply, say, supply voltage or VDD, or the ground, or the clock signals to the whole chip. So there the dimensions of the interconnects is very large, and their delays will become very large as the technology scales down. And whereas in case of the devices, we are saying that the device delays decrease when you scale down the technology. So inverse is happening with the interconnects. So the very advantage which we were getting from the scale devices is actually is nullified by the huge delays which are encountered in the wiring, which is connecting these.
Ma'am, can we wind it up, because
Yeah,
we have another speaker waiting for this session.
Yeah. Okay, we'll continue with that. So let me go to the last slides so that you can see the work which we have carried out. You can see in the references, and this is the crux of the story. Actually, when we see the applications of VLSI, particularly in the modern scenario with Industry 4.0 for sustainable development, there is no area where VLSI will not be used. So be it robotics, be it virtual reality, computer vision, IoT, or cyber physical systems, or your smart devices, or when we talk about smart grids or smart cities, smart sensors, when we talk about these things in terms of smart, we are actually referring to something which each of them will have in terms of either artificial intelligence, or which will have something which makes them more advantageous to simply grids or simply cities. So that means it is the VLSI which will lead to developments in these particular. So artificial intelligence and machine learning are the requirement in formative years, actually, for the students to continue to keep a pace with the developments, actually. And finally, to see the impact of ICs is in the form of smart devices, cell phones, car electronics, and mobile videos, home videos, and everything which comes in Internet of Things, actually. And all these interconnected networks, they have helped in enhancing the quality of life. So many research areas are there which we have discussed during this talk. And finally, to sum up, signal quality issues, and thereby apt processing is required. ICs house large systems so as to have easy portability in the e-gadgets. And finally, what is the aim? The aim is towards low power, high performance, high quality designs so as to make human life more comfortable, worth living, as this finds applications in all areas, and therefore VLSI design plays an important role and needs in discussions in platforms like this conference. These are some of the references which you can see further, and as Professor Agrawal says, you can all go to the Google Scholar and see all our related research works which we have been carrying out in this particular area. And with these words, I once again thank you, and it will be a pleasure to have some queries discussed.
Thank you, ma'am. Thank you very much. Again, I would request if any queries are there, please mention them in the chat box. In the meantime, I would request the moderator to kindly invite the third speaker so that the queries can be taken at the end.
I would like to invite Dr. Rajesh Kumar, sir. Dr. Rajesh Kumar received a BTech from the Department of Electrical Engineering, National Institute of Technology, Kurukshetra, India in 1994, Master of Engineering in Power Engineering and PhD degree in Intelligent Systems from Malviya National Institute of Technology, Rajasthan. He is currently Professor at Department of Electrical Engineering, Adjunct Professor at Center of Energy and Environment at Malviya National Institute of Technology, Jaipur, India. He is associated with several research forums, including IEEE, IET, elsewhere, and National University of Singapore. He has published numerous journal articles and papers in conference proceedings. He is the member of Research Board and Board of Studies of various universities. He is the founder of Zine Student Innovative Group. His background is in the fields of computational intelligence, artificial intelligence, intelligent systems, power and energy management, robotics, bioinformatics, smart grid, and computer vision. Now I invite Dr. Rajesh Kumar, sir, to deliver his keynote speech. Over to you, sir.
Yeah, thank you very much. And I hope I'm clearly audible and my screen is visible to you.
Yes, sir, you are.
Yeah, you are visible and audible, sir.
Okay, thank you very much. And yeah, being the last speaker of the group has advantage and disadvantage. So advantages like people are excited by the earlier presenters, new ideas, new things. And disadvantage, the time is one of the limit, which is like now I am compressed with. Well, I'll try to cover up the things in a quick way so that the things can be finished in time. Today's discussion will be on the graphs and machine learning, and I have taken many things from various platforms and the design and the research articles and try to connect them so that we can understand these things in a very simple way. Okay, so moving further, this is basically I start with that this is the building block. We call it neural network. So we have certain inputs which are coming shown in the blue color, and then the green color is a cell where we process them. We take the signals, add them, pass through some nonlinear functions, and then it will generate certain kind of output. So this one is a simple building block of a neural network, and then researchers and mathematicians across the world, they use this building block to develop various architectures and come out with new ideas. So we try to connect it that how the things they are being developed, and then one part which is now being very popular, like if you see the profile, like 2 years back, the publication in this domain, graph networks, around a few hundred, and just last year it was around more than 10,000 publications. So this area is building very fast, and we'll try to see how these things can be done. So this one single neuron, we can put it in various forms, and we study all these things when we study anything on neural networks or machine learning in our grad or undergrad classes. Combination can be perceptron. Then we can have feed-forward networks. Then we have radial bias networks. And then we can have a deep feed-forward network. So these are the feed-forward networks. You can see the connections are there, and the input is coming from one side, going towards the toward the output side. Connection can be further modified, like RNN, recurrent neural network, and then we can have a long and short-term memories, which are very popular, LSTM memories. Those who are working on timestamp data or time series data predictions and classifications, they use LSTMs. And then modified version of LSTMs are there, which are gated recurrent units. Further, we have more improvements on these things. Those are autoencoders, variationals, AEs, variational autoencoders, denoising autoencoders, and the sparse autoencoders. You can see that just the connections, the architectures, the shape, and the type of the cells, they keep on changing. And each connection or each kind of a combination comes out with something live in it, something new in it, and which can be used to address many machine learning problems there. More combinational architectures like Markov chain, Hopfield networks, Boltzmann machine, restricted Boltzmann machine, deep leaf networks. So we can see that, like during these 3-4 slides, we have different kind of combinations, how the inputs and outputs they are connected. What is, you can see that they are of different colors. A few of them they are representing the inputs, few of them they are representing the outputs. In some of the architectures, you can see the inputs are same as the outputs. In some of the architectures, you can see that they are fully connected. In some, they are less sparsely connected. In some, we have different types of functions, and that's how the different machines and different algorithms and architectures are there in the literature. More towards, like, if we are going for deep networks, so we can have deep convolution network, which are DCN, then deconvolutional networks, and then we have deep convolutional inverse graphic networks. So these are the various combinations of all these small cells. You can see, you can consider each circle of different color as a cell, and then this cell is assigned certain kind of property with certain kind of summations and certain kind of functions there. So one thing is common in these architectures, that okay, the cell is already there, it has certain kind of processing, but they are connected in particular different fashions, and that brings the some changes in the operations and some new networks which can be used for certain particular purpose. Some more on it. Okay, we have GAN, most popular nowadays. Those are generative adversarial network. We have liquid state machines, extreme learning machines, eco state networks, and likewise. So the summarized form of this one is we can develop any kind of a new network to perform any kind of a job with some changes in the connections or the operations or the functions to be used at particular node. Well, there are a lot of applications when we talk about all these approaches. Maybe playing the chess, maybe grid games, speech data, NLPs, and lot of applications. Few of them are already commercialized nowadays and are being used in a very big way. And and then people try to find out, okay, what more connections can be, more structures can be developed, so that can we have better and fast and more accurate algorithms to solve these problems. So why this approach or this agenda is important? Looking towards the graph, because many of the graphs or many of the data you can see, they are in the form of a graph. You can see they are social graphs, they are transportation graphs, there is a brain graph, we have gene graph, we have molecule graphs, and we have web graphs. So things are interconnected with each other. And now the stress is towards like, can we use these interconnections? Can we use these interconnections and then our traditional approaches over it, and then can we transform those things to generate a new kind of a architecture? So that is today's agenda, that how we can how you can use a graphs for machine learning approaches and all these things. A lot of applications can be there. Like this one, you can see the data which representation on the social media. So we can have some kind of a high school friends and family friends and then online friends and how they are linked with each other. Each one is having a certain kind of feature, and then when they are linked, then what are the common features between them? And then the next level is that can we predict something out of it or something like that. So we have social graphs around us. That is the take from this slide. And then we have, if we talk about the transportation, so we have these graphs there. Always our transportation graphs are already there, and they are a bit simple. We have nodes which give us the idea that what are that is the junction point, and then how these two junctions they are connected by certain kind of lines, and then we can use this type of graphical representation for any kind of analysis on the traffic maps and all these things there. Another very important, we can use such type of approaches for your optimization purpose. This one is TSP problem, travel salesman problem, very well known problem. Okay, then can we find out a most optimal graph that we can that one can trace, so that the total distance traveled by a person to visit all these red dot points is the minimum. Such type of problems can be used further in robotic path planning and all those areas also. Another area where this is now being used, this approach or this kind of a scheme is being used, that is medical diagnosis. So we can have, you can see the first layer, we can have abnormality of eye, abnormality of face, and the neoplasm, and then the tree is being developed, and we can see there are connections between the dots, and each dot is representing certain kind of a issue, and then can we connect all these things to identify a particular type of a disease or a related issue there. This one is one most popular domain where people are using it, and that is the drug discovery, because your molecule, if you see the molecule, it looks like a graph, and so they use the molecule and they use graph neural networks to identify or to discover the drugs there. So you can see that each H or N pair on your screen, it is connected with each other with certain kind of a bonding, and that is basically, we can consider this one as a computer science person, we can consider this one, there are nodes and there are connections between the nodes, and then how these connections between the nodes can be modified so that can we generate a good drug to address a particular type of diseases. So this one is a part of drug discovery. Many things can be done, but yeah, a more interesting part you can see on your screen here. You can see here we can have one kind of a medicine, another kind of medicine. Both have a certain kind of a graphical representation, and then yes, one of the medicine is and its symptoms or its side effects, they are known to us. We can compare, and then can we find out, okay, if the second medicine is there, what type of the side effects and all these things will be there. That can be one part of it. Another part, you can see this one is there, we can have a drug here and we can have a gene there. So how they are interrelated with each other, and then how that drug will affect that particular gene, and many things can be done. Like we can think of like protein-protein interaction, drug-protein interaction, and then drugs and their side effects and their equivalency and likewise. So a lot of such applications can be seen in the literature, where you will find that GNN is being used as a very strong computational approach for drug discovery. This one is again another application of your GNN, graph neural network. That basically you can see this one is how the COVID is spreading. So it is basically you can see a network is there, and it is a graphical network, and you can observe that, okay, how the person is moving and who he is connected with, how many people and all these things, and then we can have a particular spread of the particular disease. So this one is another kind of application where such type of approaches can be used. Recommender system. This one is again interesting application there, that okay, somebody go for certain product, and then this product is linked with connected with other types of the list and type of the products, and then from there one can get a recommendation whether the thing is good or bad. And we see all these such type of scenarios now happening on your online purchase apps or systems. So the background is basically they are linked with each other, and those linkages between the parts, they are being explored and utilized to give the final recommendation in the system. Moving further, this one is a scene graph generation, very interesting domain. You can see here in the first image, there's a person and then there's a mountain, and then there's a horse, and then can we connect these things? Okay, we have face, mountain, horse, and then generating a whole scene basically. So you pass the image and then the scene generation is there. Likewise, some applications also you'll see that person is speaking. There's a live telecast going on. At the bottom, you'll find the words are coming in a very accurate way, and that is another kind of approach is there. Another kind of application is there. So all this scene generation, because we understand from here as like these things are interrelated, like shoes, they are interrelated with leg, and leg is interrelated with so short, and they are connected with certain kind of shirt, and likewise, and then how these interconnections can be explored and to be presented in form of a graph, and then how this graph can be utilized to give the description of the particular scene. So this one is another approach, which is basically link prediction. So there are three things we can do. I'll come to that part, that what we can do from this graph scheme was. Okay, so a lot of another applications are going for the point cloud classification. We have graph constructions, we have data, and then from data we convert those data spectrums or cluster into the form of graph, and then graph can be static and can be dynamic, and then we use this graphical representation to give our final recommendations there. Like interaction, human object interaction. So you can see the image, and then image, it is identified what are the elements in the image, and then it is again connected that how these identified objects, they are linked with each other, so that we can have final phrasing of the things. Like here in the image, as a human, we can understand that the kid is just licking that knife, but it's difficult for a computer how to connect it. So it identify what are the elements there. So it identify that a person is there, knife is there, table is there, vase is there, and then from there it try to find out what is the strong, which one is having a strong relation, and that will be the final inference from the system there. Text classification, very popular now. Nowadays, this one is becoming very strong, because we know that text is nothing but a combination of certain letters, and then these letters are connected with each other. We also know that any language, there are certain things there, that there is a word, there is a noun, there is a pronoun and something, and then how they are placed, and then how they are linked with each other. So that can we have generation of the sentences, and then can we have classification of all those words and all these things there. Similarly, in natural language processing, which is very important domain of computer science, where we use we try to relate few things there, and the graphical representation is one of the very strong way to handle this type of issues there. This one is very important domain, pose estimation. At the end, I'll give you the case study where we have implemented this approach. So a video is there, and then from that video, can we automatize a system, make a system that can give it that what is the pose of a person, whether the person is running or sitting or fighting or something like that. So how it can be generated, and we can see here the human body can be represented in form of a graph. You can see here if it is neck, then the shoulder, and then other part of the body. So any one kind of a representation is like one body, and then how these representations can be connected with each other to give the final estimation. Earlier speakers, they talk about the all VLSI and all microelectronics and all these things. So chip design, again, it is a very important. Each segment can be taken as a node, and then how they are linked, so that finally we can have a very compressed chip design from it. These are the various systems, or you can say tools available, or the platforms available, which people are using if you want to work in the domain of graph neural network. So these are the tools which are already, these are the websites And support system like TensorFlow is there, TU dataset is there, Spectral is there, PyTorch geometry is there, where you can find where you can find the insight of the how the graph network works and how these libraries are already there, how you can use these libraries for your purpose. So this one is the ecosystem people are using for them. So what are the things we can do? We are talking about a lot about these graphs and graph networks and all these things. So we take a data like this, which are we think of like they are connected data, and then we frame a graph neural network. And from the graph neural network, we can do mostly 3 types of things there. One, we can identify the nodes, or you can say we can identify this person here, its feature. So that is known as node identification. Second thing is how this person and this person, they are linked. This is known as basically edge identification. And third one is this whole group, how they are similar to another group. And that is basically graph identification. Those are the 3 things, and rest of the things are just extended form of those things. So 3 things which we can do are node identification, edge identification, and the graph identification. Graph is like this, which we study in almost in the undergrad second year. Almost every branch student, they go for it, they study these things. So this one is undirected graph. What is the meaning is undirected means there is no any direction given. The nodes, they are connected, but the direction is not given. Directed graph means when the direction is given, how A is connected to B. You can take it undirected graph example, Facebook as undirected graph, whereas the directed is something like LinkedIn or Twitter is a directed kind of graph. And then complete graph means everyone is connected with everyone. These are some kind of a graph representations, and we can have combinations or hybridization of these also. So this one is a simple graph which is there on your screen, and there are it's a function of 2 things. One is V and E, that those are vertices and edges there, and we can represent it like this. So any graph can be represented by adjacency matrix, which is there on your screen. Meaning is like how V1 is connected to V2. So V1, if V1 is connected to V2, we will assign the value 1, else it is 0, like this. And each node is having certain feature. So you can take that, okay, here on your screen, there are 5 nodes. So you can say these are the 5 people, 5 persons, and they are connected with each other in this fashion. Each person is having its own feature, like what's the height, what is the age, what are the preferences, and likewise. So you can see the last this person is only connected with this one, not connected with the rest of them. So this one is just an analogy. So you take it like the representation of the graph is in the form of adjacency matrix, and each node has its own feature. And then what we try to do is when anything new come to it, or how the information is shared between them. That is the interesting part here. So what is the node level prediction? Node level prediction means we try to find out what are the features of this person. Okay, so these are the friends, and they are connected in this one, and we try to find out whether this last person is a engineer or not, something like that. So that is basically the node level prediction. Second one is this one, that we have this graph, we know the features of this one. We try to find out is there any relation between these two. Okay, so if this guy likes some certain thing, and if this guy is also liking certain things, so if they like the same, there is a relation. But if they're not, like if their likes are different, then there is no connection. This is known as edge level prediction. And the third one is basically graph level prediction. So say this one is one molecule, and we try to see that, okay, what is another molecule, or this molecule is suitable for a certain kind of a drug or not. So these are the major 3 things, and rest of the things can be considered as the extended form of these things. Okay, so then graph is, once it is done, and then we take it to the neural network, and we try to find out why people are going for it. That is the important thing we need to see. We can go for CNN and other models, but what is the advantage of using a graph? We can see it from there, that graphs are independent of the sizes. Basically, that's one of the important things. In neural network or in other models, what is the problem? You have to feed the data exactly like the way you have designed the network. But here we have this freedom that if the size and shape are different, it will consider. So no any issue. If there is isomorphism, so you can see that this image and this image. If you pass this image and this image to neural network, it give you error. But we know as a human that they are the same, that only the image is rotated. And since the graph topologies remain same, so this graph neural networks, they are free from such type of issues there. So we are more moving towards our human brain processing and likewise. So invariance and all these things are there, and because of this, they are more robust and can be a good solution for image processing or any kind of data processing. So how it works, just in a quick slides, and then we move on the one kind of a application, and then we can close the session. So you can see here on your screen, these are the graphs, and graph is there, and each node is having certain kind of features. What we try to do is, once we train it, so each neural network has two parts, train and test. Once we train it, then we have one knowledge is developed, and then we use this knowledge and we use new data to check it whether it's working fine or not. Okay, so how it is working is basically that is the processing part. So moving there, you can see here what happened step by step. Every step means every iteration, some information of this purple one is shared with this green one. Okay, and the sum of the information of this is shared with this one. So those nodes which are close to each other, or which are connected with each other, they share the information. So some of the information is shared there, and based upon the information we receive, then we update the information of this one. This is same as like, okay, we are 10% and somebody heard about some news. So then he will share the news to the next 3, and then the next 3 will share the news to the next one. So after some iteration, or after some time, you'll find that the whole news is shared with the all. And that is the same idea here also. So initially this one is having certain kind of feature. In first iteration, this red one shared with this blue one. In next iteration, this blue will go to this purple, and in the next, this purple will share with the rest of the, and then the information is shared with all. So that's a basically one kind of thought which is being used here. Okay, so this one is known as message passing. Message passing means we are sharing of the information from the connected node, and then what we do, node 1 got the information from node 2nd and 3rd and 4th, and now what it will do, it will take it and then it will perform some operation on it. It will not just take all the information and update. No, so there are certain kind of operations which are being done. So these are the information which are taken from others. Like you can see the information from H4. Information means the features from H4, features from H3, features from H2, and H1 has its own feature. And once we have this information with us, so what it will do, it aggregate the features which it received from the rest of the nodes, and then that aggregated information is used to update H1. So you can see after this aggregation and updation, some of the features of the node they are updated in one kind of a form there. So this is how this update and updation of the information take place. We can use various approaches to answer this one. So I'm coming to that one, how it is being done, and what are the various approaches. So what we can do, we can see from this figure that okay, the information start. Okay, we have aggregation here, we have updation. So updation occurs there, and then this one is iteration 1, and then iteration 2. This updated information goes back, and then again it will update, and the things keep on working like this. And normally we go for 2 or 3 rounds, not more than that. That is enough to share the information between whole of the graph there. Okay, so how we do it? So what is my basic equation? We take the information from the rest of the nodes, we aggregate them, and then we use the information of that particular node, and then we update it, and that will be the new updated information at that particular node. And this thing is used to train the whole of the network there. So what are the various applications, or what are the various variants people have developed? They have update. First, let's talk about the aggregate. So they do aggregation by the various methods. Most popular methods are mean, max, neural network, and recurrent neural network. They do the update by mean, max, neural network, and recurrent neural network. What is the meaning here? Let's take the simplest example. We have this information from all the connected nodes. They pass through a neural network, that is the aggregation. They use this information which is already there and say the mean operation is there. So then they will take the mean of the information received from the others and the own information, and that will be the updated information. So these are the few of the variants how people have developed, like, and then they do a lot of changes there. So like this one is GCN, developed in 2016 by Kirf. Okay, we have informations from the others multiplied by the weights, and then there's some nonlinear function similar like a neural network. Another variant is multi-layer perceptron edge aggregator by Jahir in 2016. So they have used here MLP instead of using the equation in this form, normalized form. They have used MLP here. Again, in 2017, graph attention network comes, so the attention weights are being used instead of using MLP or some kind of a normalization technique. In 2015, gated graph neural network comes, so they use GRUs, which are updated form of your LSTMs. And so this one is a spreadsheet which will give you a good idea that what are the other variants, like what are the variants people have developed. So they have developed on the either on the basis of graph types, on the training methods, or on the propagation steps. So these are the various subsets you can see here. So the common are spectral methods, non-spectral methods, graph attention networks, gated graph neural networks, and graph LSTMs. And each one is having, you can see the different types of aggregators. So what are the modifications so far people have done? They have made the changes either at the aggregation level or at the updation level. And that helps, that's how they have developed the new variants in there. And this I already explained you that why the graphs are better than our conventional approaches like GCN. If I go by an image, it is a structured, or if it is a text, it is also structured. If I change these nodes, my network will not work. Whereas graph are basically they are connected in particular fashion in graphical form, and they provide a good solution. So people go for all these stuffs there. The idea is taken from some kind of similarities are there from CNN. So when we work on CNN, the middle nodes, like here it is, we pass this filter and we try to find out the mean value or median depending upon which type of filters and you are using. In graph, what we do is we update the center node based upon the information of the surrounding nodes, and that's how they work together. Okay, looking towards time constraints. So I'm just giving the final formulation and then give you a small case study how it works. So this is how it works. Let's understand it. Your A is adjacency matrix, which give me the idea about my graph. If I multiply it by the X, which is feature matrix, then it will give me how my features and the nodes, they are interconnected. If I multiply it by the weight, that means how I'm learning it. And then I pass it through a nonlinear function. And then again, this one is one kind of iteration, one time iteration. Again, I multiply it by adjacency matrix and multiply another weight. This is type 2, level 2 kind of updation. And then I pass through a softmax, and that will be my final updation of my node. So this is how you can update the nodes. And then once the nodes are trained or they are updated, then you can pass any new data. It will give you answer. So coming to the case study, which we have done and published a very recent article on it. Basically, the SEMG signal-based human activity recognition. So we have these various activities, and then how we can recognize these activity. That is the basically job. So what is being done is the data they are accused, acquisition is done. Your SEMG signals they are obtained from the various places of the leg, and then some kind of denoising is performed here. And then we have performed some kind of EMD. Ensemble techniques they are being used, and then we have done handcrafted features. So like handcrafted features means like if I have an image, and then from image, what are the important features I'm going to use for my particular purpose. Instead of handcrafted, people now they are using CNN to generate the features for them. So those things can be done, and you can see here is the graph. And now this graph is generated, and then this graph is used to identify whether the person is running or sitting or jumping or something like that. So the most of the wavelet denoising as an approach to remove this noise and all this. I'm not going to that part because our discussion is something else. So the important question is how to generate a graph. So in this case, we have developed a new way, which is Pearson correlation based. So we have, when we talk about these things, these activities or these signals, they have some kind of a relation between them. So we try to relate them, we relate these signal points with each other by using Pearson coefficient. So this one is a covariance between M1 and M2, two signals, and then based upon this one, we generate this graph which is there on your screen. And then this graph is used so to identify what is the activity which are going to, which we are, what is the activity which is being performed, or these signals represent which type of activity. And this one is graph to graph matching. It is not node prediction or edge prediction. It's a graph to graph prediction there. So these are the various performance parameters when we use any machine learning technique, we try to answer these things. So these are the results you can see here, which we have obtained by using this approach, and the accuracy level is quite high. In few of the cases, it's 100. So here the S1 to S11, they are the different subjects with the different physical structures and the gender. And then few of them are normal and few of them are abnormal also. And then we try to find out, because when we have abnormality and when we try to, and we take the signals and then try to find out some trend activity, there are chances of error also. So we perform the analysis on both normal and abnormal, and you can see here the mean results here, which are quite encouraging one. The only drawback we found while working on this one was the building of the graph. That was a bit bulky or heavy data, and that is also one kind of a limitation, because for every person we have to build one graph. But once the graph is ready, then the process is very fast and the results are very encouraging. Okay, so I think I finished the things in time. So these are certain results we have compared with other approaches like SVC, KNN, and MLP. GNN results are much better than the rest of the approaches, both in normal for the normal people as well as the abnormal people. Yeah, thank you very much. Any queries? I'm really happy to answer your questions.
Thank you very much. Shiraz, please proceed.
Sir, there is one question in the chat box. How can I use ANN in wind energy generation?
Yeah, see, ANN is, you cannot, means like it's not a generator. ANN is basically you can use for two purposes. If you have data, then you can either do the classification or you can do the regression. So those are the things which you, for which you can use ANN, that, okay, I have past history, past data with me, and then I want to predict, okay, what will happen after half an hour or after or tomorrow or something like that. So if you're looking for prediction of anything, you can use this ANN for your purpose. It's not a generation, it's basically predictor. You can predict the conditions which are going to happen in the future. Any more questions?
No more questions, sir. Thank you so much for your words of wisdom, and it is a great pleasure for us to listen. I now request Dr. Anand Rajawat sir to conclude this session. Over to you, sir.
Thank you, Sridhar. Very good afternoon to all. Dr. Ajay Agrawal, Dr. Rajesh Chandel, Dr. Rajesh Kumar, Dr. Navita Khatri. First of all, I would like to thank our plenary speakers for their valuable time for this wonderful session. Sustainable electrical and electronic engineering focused on developing renewable electricity sources such as wind and solar power, systems for integrating renewable power into the grid, hybrid and electrical vehicles, energy efficient lights, motors, appliances, heating and cooling system, etc. Basically, electrical and electronics engineers are coordinating some of the today's most important innovations and trying for sustainable development. They apply electrical principles to create life-changing product, innovative technologies, or simply improve the already existing ones. From Edison's electric bulb to a modern day smart television, cell phones, solar panels, and GPS, electrical and electronics engineers have covered the way for many advancements and have illuminated, informed, and connected the world. Technology is not something to be described as static and considering the current pace and technology change and adoption. Electrical and electronics engineers are skilled to diversify the potential growth area in the next decade. Some of the most exciting and novel ideas in the field includes green energy and sustainable development, smart grids, bioengineering, connectivity and Wi-Fi, high efficiency photovoltaic cells, and many more. Now, if you talk about the session, during the session, Dr. Ajay Agrawal focuses on technologies being exploring today for better tomorrow, where and how to generate data. He covered different sustainable development goals as well as top 10 healthcare innovations. He also highlighted TIFEC vision for India like clean air, healthcare, energy, safety, and security. He also focuses on technological innovation for environment, opportunities and challenges, and various platform devices. Dr. Ranjan Chandel covered VLSI signal processing. She focuses on signal quality issues in VLSI design, signal processing in VLSI circuits, and impact and application of VLSI for sustainable development. She also covered international technology roadmap for semiconductor. During the session, Dr. Rajesh Kumar covered graphs and machine learning, very interesting topic. He focuses on traditional neural network architectures. He also represents data as a graph in different structure and different types of graphs and applications. He also highlighted concept of scene graph generation and human object interaction. He also covered example of machine learning problem with graphs and a very nice case study. Once again, I would like to thank our plenary speakers for this wonderful session. I would like to extend my gratitude to organizer for giving me this opportunity. Thank you. Over to you, Shira.
Thank you, sir. Now we have come to the end of the
plenary session 1. Before I propose the words of thanks, I request all dignitaries to open their cameras so that we can have a group photo. Thank you all. It's my privilege to propose words of thanks to all who have helped us in making this session a wonderful one. I want to express my gratitude to our speakers, Dr. Ajay Agrawal sir, Dr. Rajivan Chandel ma'am, and Dr. Rajesh Kumar sir for sharing their important knowledge and sparing their precious time with us. I extend my sincere thanks to Dr. Navita Khatri sir and Dr. Anand Rajawat sir, an entire coordinating team of SWV for their guidance and inspiration. I am very grateful to Dr. Upinder Dhar sir, Honorable Vice Chancellor of Sri Vaishnav Vidyapith Visvyadhyalaya University, who gave us the opportunity to organize this conference. I also offer my sincere thanks to all my colleagues and participants for being with us. The plenary session is followed by technical session 1 on the same Zoom link. Our guests, if wish to listen paper presentations, can continue with this session or else can leave the session. I now request Jaya ma'am and Shrikant sir to continue with the technical session. Thank you all. Thank you all for being with us.
Thank you, Shiraz. Thank you, Dr. Agrawal. Thank you, Dr. Rajivan Chandel ma'am, Dr. Rajesh Kumar, and thank you to Dr. Anand Rajawat for joining us for this session. Thank you, sir. And hope that next time we'll meet you in person, not in the online mode.
Sure.
Yeah, thank you. Thank you so much. Thank you to all of you.
Thank you, madam.
Thank you, sir.
Sir. Sir.
Yes, sir.
Sir, chalega session ke aage continue?
Sir, the session will continue with the technical session 1.
हाँ, अभी बंद तो नहीं करना ना कुछ भी?
No.
रिकॉर्डिंग जो है वो एक बार ऑफ कर दीजिए जिससे कि हमारे पास इतना सेशंस का लिंक आ जाए तो बाकी वापस आप स्टार्ट कर दीजिएगा। हेलो शादाब सर।
Good afternoon, everyone. On the behalf of Sri Vaishnav Vidyapeeth Vishwavidyalaya, Indore,
आप ज्वाइन कर लीजिए।
okay. Good afternoon, everyone. Good afternoon, sir. On the behalf of Sri Vaishnav Vidyapeeth Vishwavidyalaya, Indore, I, Srikanth Dandotia, with my colleague Jaya Sharma, welcome you all in this technical session first of PRAGYATA 2022. Innovative and Sustainable Developments in Electrical and Electronics Engineering. PRAGYATA 2022 will provide an international forum for exchanging knowledge and results in the recent developments in the fields of robotics, renewable energy, megatronics, 5G communication, and other allied subjects of electrical and electronics. This conference provides a platform for upcoming researchers in the fields of electrical and electronics by providing them an opportunity to interact and share knowledge with quality key experts who will be bringing up innovative ideas and recent updates. I, Srikanth Dandotia, is extremely overwhelmed to get this opportunity to serve as a rapporteur for this technical session 1. A very warm welcome to our renowned chairperson and presenters who took their valuable time and join us today to be a part of this conference. We are honored to have you all with us. I have a very pleasant duty of introducing our chairperson of this session, Dr. Mp Gautam, Professor SVIFS, SWB Indore, and Dr. Navita Khatri, Assistant Professor SVITS, SWB Indore. We welcome you. First of all, I would like to introduce our chairperson of this session, Dr. Mp Gautam sir. Dr. Mp Gautam did his PhD from Dr. Hari Singh Gaur University, Sagar. He has founder director of State Forensic Science Laboratory, Raipur. Dr. Gautam has established Forensic Science Department in Guru Ghasidas Central University, Bilaspur, and served as a professor of Forensic Science. Dr. Gautam examined thousands of cases of different nature referred by Excise Department of Madhya Pradesh and Chhattisgarh states. Dr. Gautam has been awarded with numerous awards like Union Home Minister Awards for Excellent Service in Forensic Chemical Science in 2004 by Home Ministry Affairs Government of India and Director Excellence Award by Ministry of Home Affairs in 2005 and moreover Lifetime Achievements Awards by Indian Academy of Forensic Science, Kolkata in 2012. He has published more than 100 research papers in the reputed national and international journals. He has also authored 2 books, and has presented more than 50 research papers in various conferences. Thank you so much, sir, for accepting our invitation and gracing this occasion. Now I request Dr. Navita Khatri to welcome Dr. Mp Gautam, sir. Can you have a video, please?
Welcome, sir.
Thank you.
Now I would like to introduce our second chairpersons of this session. Is there any problem? Okay. Now I would like to introduce our second chairpersons of this session, Dr. Navita Khatri. Dr. Khatri received her PhD from CTAE Udaipur. She has 15 years experience in teaching. She has 25 publications on journals and presented research papers at national and international conference organized by various institutes of India. She is associate members of IEI India. Her area of interest is distributed generation, voltage sag, power system operation and control, renewable energy, control system, power electronics. I welcome you, ma'am. Thank you so much for accepting our invitation and gracing these occasions. Now, without any further delay, let's begin our session. First, here is an instruction to the presenters that the presentation should be of 7 minutes duration. If it is exceeds 7 minutes, then addition 1 minute will be given to conclude your research work. No additional time will be given. Now, so we have total 10 presenters ready with their presentation. With your due permission, may I call their names for presenting the paper. Let me now call upon the name of first presenter, Parmeet Karwal. So please present your present. Parmeet Karwal, ma'am.
Yes, sir. One second. Good morning to everyone. Good afternoon to everyone present over this. Sorry for the inconvenience. Today I'm Parmeet Karwal and I would like to thank Shri Vaishnav Vidyapeeth Vishwavidyalaya Indore to give me this opportunity to represent my paper over here that's based on advantages and demerits of non-conventional energy resources. So let's move to the first objective. So the objective of the research work is to mark advantages and disadvantages of non-conventional energy sources. So first of all, my topic would be that what is the difference versus non-conventional and conventional resources of energy. And there I would conclude by saying that the conventional one are these resources are based on fossil fuels like petroleum, coal, natural gas, etc., and are called conventional energy resources, and their very known reserves are depleted to a very great extent due to its extensive usage by us. And for the non-conventional energy resource, I would conclude that the resources that are inexhaustible in nature and can be recycled or reused, carrying an infinite lifespan, marking the future of a Mother Earth, are called non-conventional energy resources. And the types are the solar energy resources, the hydro energy resources, the wind energy resources, geothermal energy resources, and biomass energy resources. And in this presentation, we will be discussing all these five types of the resources in detail. So my first type of energy resources, that is being non-conventional, as signified by the name, here we use free nature source, sunlight, to make a first solar panel energy work. Further, it has two ways to be used by us. Firstly, solar thermal route, where sunlight is directly used for tasks to be heated up. For example, heating water, cooking food, etc. And secondly, solar electrical route, photovoltaic, where light energy converts DC into AC through inverters, making path to main supply and then coming up in a use. For example, lighting up homes, buildings, industry, etc. 10,000 times more energy of sun falls on the surface of Earth than an annual fossil fuel demand. Hence, we shall mark it as the reason of appreciation. And our next energy resource is the wind energy. So this is harnessed using wind turbines, controlling wind power and using its kinetic energy through windmill, wind turbine, and transferring it to electrical energy. The blades of wind turbine play a major role as they pass the kinetic energy through wires to transformers, increasing the voltage and passing the energy to main supply to be used. A minimum wind speed, generally 12 to 14 km per hour to begin turning and generating electricity. Strong wind 50 to 60 km per hour to generate electricity through wind turbines at full capacity. Wind turbines or windmills need a lot of maintenance and hence are more expensive. And our third energy resource is the hydro energy. The project taking a lot of expense is not always safe. Mini hydel power plant and micro hydel power plant are set up to work under this water-based technology. The mini hydel power plants generate a capacity of up to 25 megawatts in a small community or industrial plant. Micro hydel power plant produces from 5 kilowatt to 100 kilowatt of electricity using the natural flow of water. It's renewable and a very simple technology. Risk of flood are increased by implementing these technology and if have a deep impact on aquatic life. So our fourth form of energy resource is the geothermal energy. As we know that the earth crust is a huge storehouse of energy and the temperature rise of 4000 degrees Celsius at core of earth and the continuous nuclear reactions taking place there is the reason of production of heat energy that are being used in the geothermal power plants. In US, this is also used in different aspects where underground water deposits is used to produce heat in the houses. But talking on large scale, even geothermal power plant has three various types as follow. That is the dry steam power plant, flash steam power plant, binary cycle power plant. And we are not going that deep into the topics, but its power generation is very high as compared to solar and wind energy sources production. It needs no fuel for production and it is pollution-free process covering minimum land as compared to other power plants, but it is not available universally and are very, very rare. So, fifth type of energy resources are the biomass energy resources, where the organic waste produced from plants and animals is called biomass. And this organic waste is burnt with fuel technology based in power plants where slurry, that is the waste mixture, is formed in mixing tanks and makes its way to intel chambers, gas tankers, anaerobic digestion process, exhausting furnace or boiler in form of steam reaches turbine coupled with generator and hence electrical energy is produced with the removal of spent slurry, which is later also used as manure. Its maintenance rate is low. That is, we could say that it's cheaper as compared to the other ones, and the installation process and overall it's less expensive in comparison to everyone. So, after all the study of the five forms of the energy resources, my comparison and arguments say that taking economical aspect under the study, both solar and biomass power plants are likely equal as the investment for 1 megawatt solar plant has been 4 crores and for biomass it varies from 3.5 to 4 crores, which hardly marks any major difference. But now, moving next to maintenance issue, the power plant requires a proper economical maintenance issue. The solar plant require a Am I audible?
Yes. Yeah.
Yes, ma'am. Yes, ma'am.
Okay. Require a proper economical maintenance after some period, but it's not same for biomass power plant, as after the installation, no extra maintenance money is required. As qualitatively also plants and other forms of biomass are regenerate themselves, while solar panels cannot. Once broken, extra repair cost is added to it, or else energy output would be drastically decreased. Talking about the efficiency for solar energy conversion is less than 30% on average scale, whereas the biomass energy conversion efficiently settles at the rate of nearly 10% to 15%. And the very obvious reason for which biomass is not considered over solar power plants is that it causes a lot of environmental air and noise pollution. Due to standard of living for people staying nearly decreases as it produces a stinky, terrible smell all day. So my final conclusion is that from very less points, we could say that solar energy wins the race over all energy resources till the date. Its disadvantages are still less as compared to energy resources, and it marks more points of efficiency. So thank you for the presentation. And if anyone wants to ask for some questions and queries, I'm here to answer you. I'm welcoming all the queries and question answers.
Thank you, ma'am. Now, I would like to invite our chairperson to ask the question if they have any. Now, let me now.
Sir, आप mute है गौतम sir.
Parmeet?
Yes, sir.
Parmeet, you have presented in a very nice way.
Thank you, sir.
But some details should be given in the conclusion. Only 2-3 lines have been given. You should have mentioned about the present status of utilization in our country and another country, foreign countries. Which one is best? There should be a comparative chart also. You must include in your paper.
Yes, sir. Definitely.
That will be more informative, and rest is okay.
Thank you, sir. Thank you so much. And I will definitely keep these points in mind.
Okay.
Thank you, sir.
Okay. Thank
Let
you.
me now call upon the name of second presenter, Ramakant Deshmukh. Please present your presentation. Ramakant Deshmukh.
Sir, is my screen is visible?
Okay. Parmeet Karwal. Your screen is not visible right now.
Yes, my screen is visible.
Okay. Visible.
Okay, so very good. Good afternoon, everyone present over here. I am Ramakant Deshmukh from Medicaps University, Indore. First of all, thank you for Shri Vaishnav Vishwavidyalaya for giving this chance to represent my research paper on International Conference PRAGYATA 2022. So we have done our research on the electric powertrain for 6-seater electric vehicle. Usually, this topic is at boom nowadays, electric vehicle. So what is a powertrain? A powertrain is assembly of heavy component that thrust our car motions. It includes some motor transmissions, drive shafts, axles, differential, battery, and a controller. Here is a diagram, the basic diagram of any of the electric vehicle, which are usually present nowadays from a 3-seater to a 4-seater. First of all, here is a transmission system, well known as a differential, which connected with a motor. And here motor is usually used to convert an electrical energy to a mechanical energy by following a conservation law of energy. Energy neither be created nor be destroyed. It can be transferred from one form to another form. So to control overall control of the electric vehicle, we are using a controller attached with a motor as well as a battery, which is today is well known for a lithium-ion battery or lithium ferrophosphate battery, attached with a BMS, which usually used to control a whole battery, well known as battery management system. Here is overall the basic diagram. systematic attachment of all the components with in an electric vehicle. The EV ECUs when stand for electronic control unit, accelerator, brake, and selectors. All. And here is the front wheel with attached with an accelerator, which with the controller too, which used to boost or accelerate the electric vehicle. So the main important part, a motor which used to drive an electric vehicle. So a motor is usually used to convert mechanical energy to electrical energy by laws conservation of energy. We use a PMSM, permanent magnet synchronous motor. The motor is attached with a 42-inch differential. And why we use a PMSM motor? The PMSM motor is a hybrid version of an BLDC motor as well as an induction motor, which usually used to give high torque at the low speed. Here is the specifications of our motor, which we use in our electric vehicle. The brand of Datai, the power of 5 kilowatt, rating of 72 volts, and RPM of 4,500. Rated torque of our electric vehicle is 35 Nm, and no load and rated current of our vehicle is 105 and 9, and waterproof level of approved by IP67. Another important components of electric vehicle is a controller, which usually used to control overall actions of an electric vehicle. It is an electronic gadget which usually used to connect between the motor and the battery. The electric vehicle controller is the electronic package that operates between the batteries and the motor to control the electric vehicle speed and acceleration, automatically recognize the motor phase angle and the motor right spins directions. It can be conducted by a self-steady wires. When the battery voltage becomes lower, the current will also lower to keep the normal running. It protects the battery and extend the battery life and increase the running distances. So here is overall to control an action of electric vehicle, the controller is provided by different actions is being provided by a controller. Another, here is the specifications of our control. The control can be worked on 42 to 72 volt. The max current delivered by our control is 150 ampere. And under voltage of our controller is about 41.5 plus minus 0.5 volt of battery, 48 volts, 60 volts and 70 volts. For 60 volt battery, 50.5 plus 0.5 up and down of battery of 60 volts, and 63.5 plus minus 0.5 volt battery of 72 volt up and down under voltage. Total voltage provided by our control is about 1.2 to 4.3 voltages. The environment temperature with stand our controller is about -20 to 50 degrees Celsius, and our controller can capable of a CAN mode supply to. The CAN mode stands for control area network, which control over all parameters of a battery too. The another important parameter of an electric vehicle is a battery, such as in IC engines, petrol give room to an IC engine. Here battery give room to a motor. So we use a lithium ion categorized under lithium ferrophosphate battery. The several distinctive features of electric LFP batteries are given below: better power density, low discharge rate, plate discharge curve, less heating, higher number of charge cycles, increased safety. Increased safety means nowadays you heard many news related to electric vehicle, Olas especially. The electric vehicles are burned due to fire. By using the case study of on the electric vehicle, they get to know that lithium ion due to this summer days high temperature. So in electric vehicle, battery play a vital role. So to protect and safety required by a owner, so we have to see on the safety factor too. And LFP battery which stands over all the factors of this. LFP batteries are environment safe and structure stable. They are well suited for an application that requires high load current and endurance. They do not heat up easily and are relatively cooler than the other batteries. So here are the specification of our LFP batteries, which can capable of providing a nominal voltage of 73.6 volts, rated capacity of 100 Ah, max discharging current of 300 amperes, recommended discharging current of 100 amperes, and max charging current of 100 amperes too. Recommended charging current 20 amperes and charging cutoff voltage of 83.95 volts, and discharging cutoff voltage is 57.5 volts. So here are the overall calculations which are to be needed in the powertrain of any of the electric vehicle. First of all, the calculations done on a torque for a speed gear, as we use a 42-inch differential, having a two gear shafts, and the overall torque provided by motor to a differential. The overall calculations done on overall specification given on upper sides. So the front, here are the VL RPM of our motor and transaxial ratios and this overall. Another calculations done on the acceleration force. When the throttle is pressed, how much force required to by electric vehicles to be covered. So here are the basics formulas to cover any of the electric vehicle to get an accelerate mode. The electric vehicle designs, the gross weight of our electric vehicle is 1 ton, 1000 kg. The top speed provided by our electric vehicle is 41.04 km/h. Acceleration time required to accelerate is 11.51 seconds. Our electric vehicle can capable to run any of the gradients about 20 to 25 degrees. And this whole vehicle designed to run on an asphalt road or a Dharma road. Here are some basic calculations which usually used in any of the electric vehicle to run on a basic road or from such as calculating the rolling resistance, calculating the gradient resistance or a gradient resistance. Here in mechanical engineering, resistance is analogous to a force. So here is the rolling force, gradient force, and finding the entire tractive efforts which provided by on our electric vehicle. Here the all tractive effort forces, rolling forces, gradient forces, and elevation force. So here overall the force required on our electric vehicle is 1465 newtons, and the torque required on an electric vehicle. Here the calculations related to our electric vehicles too. The reality maximum checkup and tractive force. Tractive force means torque means the overall torque provided by a motor to a differential and to cover the gradient of 20 to 25 degree. This whole is required. So overall calculation of our project of electric powertrain of an electric vehicle of 6-seater electric vehicle. Here is the conclusion, which we have done research. The component of this powertrain are selected after the calculation and research with the help of research paper and books. For the requirement of our vehicle, we have selected a 5 kilowatt 72 volt motor, max RPM of 6000 and rated torque of 35 Nm. And speed controller can be transfer a peak power up to a 10 kilowatt. And battery used in our electric vehicle is of lithium ferrous phosphate of 72 volt 100 Ah. The vehicle using a powertrain having the following specifications. Here are the specifications which given before. Vehicle maximum weight is 500 to 550 kg and gross weight, including the passengers too. Our weight goes to 1000 kg to 1400 kgs. The max speed provided of our vehicle is 40 km/h. By carrying a 6 people too, our vehicle can range up to a 50 km per charging. Inclination gradient up to 20 degrees, or it can be more, depend upon a passenger. This powertrain includes 42-inch dual gear differential. Transaxial ratio of our differential is about 10.5. Torque produced by a wheel is 367.5 Nm, and acceleration is 99 meter per second square. Here are some references related to an electric vehicle. And thank you, sir. And if you want any questions related to this research paper, you can ask.
Thank you, sir. Now I would like to request the chairperson, sir, please ask question if you have any.
Ramakant?
Yes, sir.
Have you installed this vehicle in your university?
Yes, sir. Actually, we are manufacturing this. Right now, it's in manufacturing period, and we are soon going to run this vehicle in our college.
So, because you have mentioned about the 6-seater.
Yes, sir.
6-seater meter 4-wheeler.
Yes, sir.
4-wheeler or 6-wheeler?
Sir, 4-wheeler.
Achha. You have mentioned about the battery.
Yes, sir.
Lithium battery.
Yes, sir.
And
yes,
you have
lithium ferrophosphate.
Lithium ferrophosphate. And you have also mentioned that some fire accidents took place.
Yes,
due
sir.
to battery, this environmental factors, due to
Yes,
heat or whatever it may be. You should give some more details about this battery. What
Okay.
are the advantages? However, you have given 2 or 3 points. So it should be compared with the traditional batteries.
Okay, sir.
Yes. Which are generally used in the vehicle. So what are the more advantages? It is a more advantage in which term?
Okay.
Yes. Because lithium ferro is not very cheap in the price.
Yes, sir.
It is costly one.
Yes, sir.
So whether it will enhance the cost of the vehicle?
Yeah.
Okay.
Yes, sir.
Your efforts are good and keep it up. Yeah, very good.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir. Next presenter's name is Kuldeep Pandey. Please present your research work.
Okay, sir. Sir, my slides are visual. Hello.
Yes.
Okay, sir.
No. Yes.
My
slide is
slides
visible.
aren't. They are
Visible,
not
visible.
visible. They are visible. Okay. So greetings to all. I, Kuldeep Pandey, is here representing my team and like to brief you all about the project me and my team has worked on. We have worked on design and analysis of small-scale wind turbine for a domestic purpose. We were 4 team members, and our guide was Mr. Santosh Raghuvanshi sir, who was a professor at Medicaps University. My fellow teammates are Akshat Parmar, Alpesh Sheikh, and Rajiv Lochan Mishra. We wanted to create this is a table of content for this PPT, where we're gonna talk about the introduction, literature review, and all other stuff. So introduction: as human population has increased day by day, the need for power has increased exponentially. This need for power has created us, uh, has made us to depend on fossil fuels to fulfill our power needs. But fossil fuels itself create a large carbon emission, which is really harmful for our environment. It is really necessary to adopt to renewable sources of energy to decrease the harmful effects of using fossil fuels for our energy needs. This is the graph for last 100 years. The we can see in last 100 years the carbon emission in throughout the globe has increased exponentially day by day. To reduce this, we have to adopt to renewable sources of energy like solar, wind, or hydroelectric, which are renewable and doesn't emit any amount of carbon in the air. This is the literature review which we followed throughout our project. For creating our wind turbine, we have looked into various papers, and our one of the our main objective was to decrease the cost of creating such turbines. We wanted to increase the economical feasibility of a wind turbine. As of now, if a home has to set up a wind turbine for its need, it has to the economical barrier was much high. A normal Indian household cannot uh, cannot don't have the money for that kind of work. So one of our main objective was to make it economically feasible. So we have tried many cost cutting methods. We just wanted to create a small scale wind turbine that can power a average Indian household. This was the methodology for our project, where we have a predetermined predicted wind speed for which our wind turbine gonna work. And if the wind speed is below that determined wind speed, then there gonna be a battery that gonna fulfill the needs up until the wind speed uh, is as per our needs. Uh, these are the things that we have used in our project. We have used towers, a tower, propellers, blade, rotors, wind speed. We have tried to calculate the wind speed at various locations to determine which place gonna be the perfect place for installing such turbines. Here we have a small detailed diagram for our windmill which we have created. We implemented a gearbox because sometimes wind speed can be dangerously fast and it can damage the rotors or blades itself. So we have implemented a gearbox to reduce the to control the rotation of the blades. This is a oscillation circuit for our inverter, which where we have connected base and collector of two NPN transistors with 1K kilo ohm resistors in between. Also, we can add 2 capacitors at the AC output to filter the noises. These are the calculation we have used. During this calculation, we found out that the maximum efficiency of a windmill cannot be greater than 59%. But through our experiments, we have found out our wind turbine doesn't reach that close to the maximum efficiency. We found out that our windmill is 48% efficient. There might be some miscalculations, so we again did the testing, and it was below 45. Uh, these are the data which we have collected for. We have run our wind turbine for 2 hours, and these were the data which we have collected. An average Indian household needs 90 kilowatt hours per month, and our windmill, if worked efficiently, if worked at max output, it can generate 85 kilowatt hours per month. These aren't data collected throughout a month. It was a data collected within a day, but these are the estimation if the wind turbine is run properly for a month. This is the same chart for this table, which shows different quantities like power generated, energy output, voltage, and current. Here voltage is multiplied by 10, so the actual voltage in the graph that shows is 1/10 of the shown quantities. Our conclusion was a small scale wind turbine was successfully designed. We are currently trying to install it at Medicaps University in Indore. The power generated was a function of wind speed. As wind speed increased, the power output increased as well. These were the two major conclusions for this project. Our future scope, as India is adapting to renewable energies, our PM Narendra Modi said that India is trying to cut down its fossil fuel dependency by 50% in up until 2050. So our adapting to renewable sources of energy at individual level can increase the effectiveness of these claims, and we can reach that goal even sooner than we intended to. These are some references which we have used for our project. These are some websites which we have used for this project. I'm sorry for the noises in my background. These are the same references. Thank you. If anyone has any kind of question, they can ask me. I would love to give response. Sir.
Kuldeep?
Yes, sir.
So you have designed a wind turbine?
Yes, sir.
For domestic
yes,
purpose?
Yes, sir. This was the prototype.
You just come to the conclusion.
Okay.
Show the slide. Now you see the fourth point.
Okay.
What is fourth? The project was successfully able to generate energy, but the effectiveness of the wind turbine was less than intended. So what efforts you have made for this?
Sir, as we have done many cost cutting methods to make it economically feasible, the power output.
Your vision for the objective was very good. Okay, about the cost, you would like to minimize the cost. This is another thing. But for the fourth point, which you yourself is making remarks,
okay, sir,
the effectiveness of the wind turbine, so you just take the suggestions from your professors. This is a very good.
Okay, sir. I got your question. So we have used a stepper motor as a generator for our wind turbine. We used it because a small wind speed can also generate some output. We first we were in dilemma that what kind of motor should we use, but we thought even if a small rotation can generate some output, it's gonna be enough for lighting a bulb. So we used a stepper motor. We could have used a better kind of motor which can increase the output by some margin.
In future, you improve its effectiveness.
Okay, sir. Yes, sir.
These such type of business is generally required. You have also mentioned about our honorable Prime Minister, what he's thinking. And it's a very good sign that you people are listening and working towards that. Okay. Next.
Okay,
thank
sir.
you.
Thank you, sir.
Kuldeep, I have one question.
Okay, ma'am.
Hello. But this is what is the capacity of your this model, proposed model?
Ma'am, our motor, you are asking about the motor or
No,
the
how much
turbine?
generation is there from this prototype?
Ma'am, the maximum generation which we have seen was 118 watts.
118, okay. Means 0.
Yes, ma'am.
Near about 0.1 kilo.
Yes.
Okay. Okay, so this is just a prototype.
Yes, ma'am. This is a prototype. But we
So
are intending to.
if we want to implement for the house, what changes you want to make?
Ma'am, we have used PVC pipes for blades. During the testing, we found out that blades are the material we have used for blades isn't that strong. So we have to reinforce it with some aluminum strips. So in future, if we recreate it, we gonna use a different kind of material which is strong enough to sustain a larger wind speeds and doesn't break down.
What about the frequency? How you will manage the frequency, because it will have variable speed. Then what
Yes, ma'am.
provision you made for the?
Ma'am, we have created an inverter which we have installed it already. There is a battery. The power which gonna be provided to a home will be provided through a battery. Windmill will only charge that battery, and that's how it's gonna work. And there is an inverter and an oscillation circuit to convert it back to AC.
Okay, okay. Thank you. Thank you.
Okay, ma'am. Thank you. So I can leave now?
Yes. If
Okay.
you
Okay, ma'am.
wish to listen other paper presentations.
Okay. Okay, ma'am. Okay. Okay, ma'am. Thank you.
Shrikant. Next. Start kara.
Yes, sir. Sir, is my screen visible?
Okay. Proceed.
Okay. Good morning, sir. My name is Shraddha Gajpee and my topic is new ANN-based approach for modeling of robust droop control for proportional load sharing between parallel operated inverters. Introduction. These days, increasingly distributed generation, that means DG, and renewable energy assets, for example, wind, sun, and tidal strength, are connected to the public grid through electricity inverters. They often form microgrids before being related to the general public grid. Because of the availability of high current power electronic devices, many inverter areas units are inevitably required to be operated in parallel for dynamic and or affordable applications. One more reason is that parallel operated inverters offer system redundancy and high dependableness required by essential customers. A natural topic of parallel operated inverters is a way to share the load among them. A key technique is to use droop management. which is widely employed in standard power generation system. The advantage is that no external communication mechanism is required among the inverters. This allows sensible sharing of linear and or nonlinear loads. Microgrid management is associated isolated mode in complex than grid connected mode. The voltage and frequency of the microgrid are managed by the first grid if it is grid connected mode. On the alternate way, the voltage and frequency management and even electricity management is done by microgrid in isolated mode. The droop control theory. In a complicated power system, when various DGs are connected to the microgrid, the power sharing among them is made accordingly with the help of control strategy called droop control. Droop control also allows the system to disconnect smoothly and reconnect routinely to the complicated power system. The function of droop control in power sharing is that it controls the active power based on frequency droop control, and it controls the reactive power based on voltage control. The frequency and voltage can be manipulated by regulating the active and reactive power of the system. In a complex power system, when multiple DGs are connected to the microgrid, the power sharing among them is made properly with the help of a control strategy called droop control. Now, droop control also enables the system to disconnect smoothly and reconnect routinely to the complex power system. These are the equations, active power and reactive power. P is active power and Q is reactive power. In LV microgrid, when R is greater than impedance X, power dispatch equation is given by P is approximately equal to V1 square upon R minus V1 into V2 upon R, where V1 is receiving end voltage and V2 is sending end voltage. R is the load. In LV microgrid, when R is greater than X with small power angle del and small angle difference V1 minus V2, the active power P depends mainly on voltage difference, that means V1 minus V2, while the power angle del and frequency depends mainly on reactive power Q. Thus, the traditional frequency droop control through active power and voltage droop control through reactive power used in HV levels, that means high voltage levels, is not functioning very well on LV, that means low voltage network based microgrid. As a result, the voltage control would be implemented through active power and frequency control through reactive power production or consumption in a converter and LV network based microgrid, means V1 minus V2 is equal to I into R. So in conclusion, we can easily say that frequency is approximately equivalent to Q. Frequency is dependent upon reactive power and V is approximately dependent upon reactive power. These are the parallel, this is the system parallel operated inverter in microgrid configuration. Now, robust droop control. The conventional voltage droop control can be rewritten as follows. That means delta E is equal to E minus E star is equal to NP. This is the equation for active power, where delta is 0 under grid connected mode. However, delta E cannot be 0 for isolated mode because the active power could not be 0. Another problem in the voltage droop, in the voltage drop caused by droop and load changing effects. Smaller voltage drop can be achieved by selecting a smaller droop coefficient. A larger droop constant need to be selected to achieve fast response. The voltage drop can be obtained by adjusting E star minus V naught. This strategy is known as robust droop control. This technique is a control strategy that modifies the droop equation by deducting the RMS of inverter output voltage from the voltage set point. This method compensates the voltage drop because of the droop and load effect. It maintains the voltage, it maintains the lower voltage within the rated value, but with poor reactive power sharing. This robust droop control can be expressed as follows. These are the equations. That means E is output power and omega is frequency. Now, in proposed controller, the droop control is an effective method for parallel operation of voltage source without any communication among modules. However, in low voltage microgrid, the line impedance is predominantly resistive that causes the control of active and reactive power can be no longer decoupling and then finally influence the power sharing accuracy among inverters. It has been demonstrated that adding a virtual output impedance VOI in control loop can regulate the total equivalent impedance TEI between module and common bus to be predominantly inductive, thus improves the power sharing accuracy. However, this method causes another problem that the common bus voltage will fall because of the voltage loss on the VOI. So hybrid control strategy is used as a primary control where virtual impedance robust loop control is used along with artificial neural system. In secondary controller, current controller is used. The prime motive of current controller is to strengthen the inverter output current and track the reference current taken from the grid. The proposed controller consisting of a current reference taken from the grid and the actual inverter's output current, then the generated error signal is fed to the PR controller. Further, the output is used to generate a switching signal for the inverter using unipolar modulation. Now, what is ANS, the artificial neural system? Artificial neural system is a collection of neurons, simple and immensely interconnected processing units. They work together in a friendly way to solve problems. They are in a nonlinear type with outstanding properties such as fault tolerance. Sir, I'm just concluding. Self-learning ability, these are the ANS. Now, these are the figure. Yeah, these are the microgrid implementation in MATLAB. Now the resultant discussion, the structure shown above and with the proposed method has been verified in 2015 version of MATLAB Simulink, consisting of two numbers, single phase inverters. The primary loop regulator actually consists of virtual static impedance control with artificial neural system, and the current regulator is used as a secondary regulator to achieve proper power distribution for the linear load having impedance magnitude of Z is equal to 0.25 and impedance angle is 46.1 degree. Now these are the output voltage and current with the help of two inverters. Now this is the real power sharing by the two inverter, real power sharing by the two inverters. These are the reactive power sharing by the two inverters. This is the graph for output frequencies by two inverters. The conclusion, the isolated microgrid using virtual impedance robust loop control with artificial neural system as the primary controller and current controller is used as secondary. The management and operation are examined and simulated. The ANS is trained using data set collected from two single phase DGs. To overcome the disadvantage of power sharing issue, frequency and stabilize problem in the generalized loop control technique, this method is recommended as the essential control. To check and improve the work for proposed method, it is tested on two DG system with linear load. From the frequency and power sharing graph, it very well may be achieved that the proposed strategy in primary and secondary control defeat the disadvantage of generalized robust loop control, stabilize the frequencies within the range, and appropriately dividing the actual amount of reactive and active power between the DG units, taking into account the output impedance of inverters and complex line impedance. These are the references. Thank you very much.
you have any question, please ask.
Navita madam. Any question, Navita madam? Please comment on this paper.
Sir, no questions from my side.
Okay.
Yes, any questions from the audience?
It would be better if some participant will raise their hand for question. Because we can only give the suggestions. We don't have any question. It would be better if the participant will raise their hand for question. If there is nobody, the next can be called. Shrikant, you can call another one.
Thank you, sir. Thank you, ma'am.
Okay, Shraddha.
Thank you, sir.
Who's next? Now start, Ashwin.
Ashwin, start your presentation.
Okay. Start.
Yes, sir. First of all, hello and good afternoon, everyone. My name is Ashwin Pathak and I am from Prestige Institute of Engineering, Management and Research, Indore. Today, I am going to present on our team's work on the topic health monitoring and controlling of three-phase induction motor. So by the end of this presentation, I am hoping to give you a better understanding of our purpose for this research paper. So let's start. First, I start with a brief overview of this research paper. So what is objective and scope? As we know that the performance of induction motor is directly based on its various parameters like current, voltage, speed, vibration, and temperature. And in faulty conditions, the current or voltage may increase beyond its rated value, where the temperature may increase or due to that mechanical failure, any unwanted vibrations may occur, which can cause the damage to the motor. So by monitoring these parameters like current, voltage, temperature, and vibration with the help of sensors, any severe damage can be avoided and our induction motor can be protected from the unsafe conditions. We can also turn on and off the system without any physical contact or remotely. So first of going to the abstract, as we know nowadays the induction motor has remained most popular type of motor for industrial application. Either it is domestic or industrial application, we can see induction motor everywhere. And the working of this induction motor depends upon various parameters, maybe temperature, current, voltage, and its mechanical strength. So by monitoring and controlling of these mentioned induction motor parameter is very essential in many applications and also for the reliable operation of the motor. And there are several different techniques also available in the market for the same. Our paper deals with the monitoring of all the parameters and controlling of these three-phase induction motor parameter remotely with the help of GSM module. So for this purpose, we are using a module of sensor which monitors the parameter like temperature, current, humidity, and voltage of induction motor and send the data to the microcontroller unit, which will process the data and display the status of the motor on the LCD display, as well as will also transfer the information on the mobile phone. The system, our proposed system also presents the automatic and manual control methods to stop or start the induction motor to avoid any system failures through switch and coding functions. The implementation of this scheme will increase the working efficiency of machine by continuously monitoring to avoid breakdowns and also to determine the preventive maintenance. We have also simulated and tested this proposed system on Proteus 8 software. So for this purpose, the hardware components which we are using is a temperature sensor LM35, which is used to detect the temperature of the motor. For measuring voltage, we are using a voltage transformer. For current sensor, we are using ACS712 module, humidity sensor HR202, GSM module, LCD display, and microcontroller 8051 family. For simulation purpose, software description we are using Proteus 8 professional software, which is used for the simulation of different circuits, Vision for 8051 family, C51 compiler, and embedded C programming, which is mainly used for the industrial application. Now coming to the working, that how our proposed system works. So first of all, let us go through the block diagram and understand step by step. All the sensors like voltage, current, vibration, and IR sensors and temperature sensors, these are connected to the motor either physically or at a distance to observe the condition. Outputs which are obtained from all the sensors is fed up into the respective operational amplifier LM35, which is a combination of two op-amps for the filtration process to remove the extra noises. And from this IC, we are getting the output as 1 or 0 in the form of voltage, which will be fed into the microcontroller. As per the obtained values and the data, the embedded C program, which is burned in the microcontroller, will analyze the data and gives the output to the control system. The outputs from the control systems are given to the electromechanical drivers, mainly consisting of relays and transistors. This driver will control the running of the motor as well as can also switch on and off the motor remotely or by physical contact. One more output from the microcontroller is given to the GSM module. This module transmits all the information given by controller, which can be received by any specific cellular phone connected to the module. Another output from the microcontroller is given to the LCD display, which shows the status of the motor, either it is safe state or in unsafe condition. Now coming to the conclusion, our proposed system provides diagnostic information of the motor when combined with computerized data, which we have fed in the microcontroller, and the processing techniques. So this acquisition hardware can be used successfully in the monitoring of motor without requiring access to the motor. Our developed system is just a prototype to show the working of the proposed idea in a small level. In this project, we are using a 3 horsepower induction motor, and it can be seen that induction motor can be easily monitored and controlled through a simple control circuit designed under microcontroller environment. For this purpose, as I mentioned earlier, we are using a GSM module here by which all the information about the status of the motor will be sent to the mobile phone. We have simulated this system operation under Proteus 8 environment successfully and coated with embedded C, which showed us positive and stable result. The use of 8051 over this controller is preferred just because it's cheaper price and it is one of the fundamental microcontroller, and also it's a simple circuitry compared to the other systems. So this was all about by myself, and applications. This project can be used for irrigation purposes, and it can also be used to prevent excessive heat produces in the machines. It can also use to monitor the induction motor while running in the system. Multiple remote data collection point can also be included, and machine-to-machine eco-free system. So this was all about by myself. Thank you so much. And if any questions regarding so, sincerely invited.
Do you have any question?
Ashwin,
Yes, ma'am.
I want to ask whether your proposed system can be realized by Arduino system or it is only possible by microcontroller?
No, ma'am, it can also be designed with the help of different microcontroller, either Arduino or Raspberry Pi. We just use microcontroller 8051 because of its cheaper price. And as we know that in Arduino, we can use different programming, and our team members are familiar with the programming of microcontroller 8051. That's why for the ease of understanding, we use it.
Okay, so for ease of understanding, you have used
Yes, ma'am.
8051.
Yes, ma'am. And for the economic purpose also.
Have you implemented in real world implementation has been done, or it is just a prototype?
Oh, no, ma'am, it is just a prototype and we only simulated this on the software basis. Hardware implementation is right now going on. Yes, ma'am.
So what are your suggestions, or what I expect if we apply it to the real system? What changes you will make?
Ma'am, first of all, we will use, like as you mentioned about Arduino. So Arduino is one of the most used microcontroller right now. So we will use Arduino in place of microcontroller because it has so much functionality either in coding purpose or in the hardware. So this one change we will go through, and one more change in the future, if we are going to implement this in a hardware basis, will include IoT in this, with the help of which we can use real-time monitoring and controlling.
Okay.
Yes.
Any other questions from audience?
Next presenter's name is Saksena. Sir, please share your presentation.
Prashansa, share your screen.
Share your screen. Prashansa, share your screen. Oh. The next candidate is Prashant Namdev. Prashant Namdev, please share your presentation. Prashansa, you will come after the Prashant Namdev. Prashant Namdev. Next candidate is Deepak Rathod. Sir, please share your presentation. Sir. Deepak Rathod, sir. Okay, Deepak, sir. Your presentation.
Hello, Srikant sir.
Yes, sir. Yes, sir.
May I start my presentation?
Okay, share your screen, sir.
Yes, sir.
Deepak, sir, share your screen.
Okay, sir. Sir, my screen is visible now?
Yes, sir. Yes, sir. No problem.
Okay. So, good afternoon to one and all. I am Deepak Rathod, going to present here my topic, energy conservation audit in thermal power plant, and it's a case study. So, these are contents of my presentation. Now I will talk about the scope of energy audit. These are some major areas where the audit has been done. And the final result of the audit is summarized in this table. We can see from the table that these are the energy saving or energy conservation measures, and these are the saving recommendations. And this is the approximate amount investment by implementing the suggestion given by us. And this is the payback period. So by doing all the calculations, we can see the total amount of saving, investment, and payback period after applying the recommendations given by us. So these are the total, this is the total saving potential per year. It is the 91.15 lakh, and this is the electrical saving potential per year. So total energy they can save by implementing the this recommendation is 4.57 mega units, and approximated investment required is 142.5 lakh and this is the overall payback period is equal to 19 months. In this time period, they can recover their investment amount. Now I would like to share some of the suggestions which will improve efficiency of the different electrical and mechanical equipments used in the power plant. So there are different types of recommendation. The first is immediate measures. So by reduction of the service air pressure to 3 kg per centimeter square, reduction of the lighting supply voltage to 230 volts, and reduction of lighting supply voltage to 230 volt in CHP. This is the combined heat power system. And these are the short-term measures. Performance improvement in ID fans, that is the induced drop fans, and performance improvement of chiller compressors B and C, which are used in their AC plants. And these are some long-term measures by installing of VFD, of CEP condensate extraction pumps, and by installation of VFD for their FD fans, they can save huge amount of electrical energy. So this is the general introduction of the power plant. So Tata Power Plant is a captive power plant. Its capacity is 100 megawatt, which is situated at Mithapur in Gujarat. So this is the total outcome of energy and saving amount in rupees, which I already told to you. So first is the condensate extraction pump. In this table, we have collected all the required data from the plant, and by doing all the calculations, we say that the efficiency of the CEP is 46%. We can see from the table the efficiency is 46%, which is less than the design efficiency, because the lower efficiency is due to the throttling operation. The throttling operation at flow control valve to maintain at the DA level, and the flow is varying during the audit. That would be the 230 to 250 meter cube per hour. So our suggestion is looking at the varying load requirement, it is suggested to install VFD, that is the variable frequency drives, to control the speed of CEP in the place of control valve. So by installation of VFD will remove control valve and bypass line, and flow is controlled through varying the speed of motor, taking the signal from DA level, that's the de-rated. Similarly, installation in the power plants has resulted in a saving potential of 20%. So if we install VFD, so efficiency of that system will be increased by 20%. And by these calculations, we can observe this is the average power consumption by 2 CP, and power saving potential at 20% efficiency is 38.4 kilowatt. And this is the energy saved per year. So this is a huge amount of energy they can save by installing VFD instead of their control valve. So this much of amount, approximately 6 lakh, and the investment required for 3 VFD is 15 lakh. And the payback period is 30 months. So similar analysis is also done for FD, that is the force drop fan. So in this slide, we can see the overall efficiency is 26% and 28%. So there are two FD fans, FD fan A and FD fan B. So this efficiency is very less as compared to the design efficiency. It is due to the laser flow and pressure requirement by the combustion process and the pulverizing mills. Hence, it is suggested to install again VFD for both FD fans, keeping IGV. IGV is the inlet guide vanes and the damper position fully open for fulfilling variable combustion air requirement of the plant. This will reduce the power consumption of FD fans and will increase the efficiency of the fans. So the detailed power saving calculation is given below. So there are some formulas which I have used to calculate these all calculations. And again, by installing the VFD, so total amount saved per year is 27.5 lakh by saving this much of electrical units. And the total pay period is 43 approximately 44 months. And similarly, the calculations for IT fans also. So for IT fans, for fan number A and the fan number B. So for fan number A, the computed efficiency is 40% and for B is 60%. So it is very less as compared to the design efficiency. So what is our suggestion? The fan efficiency calculated for IT fan A is 40% and B is 60% respectively. So suggestion is that to replace the fan A impeller and to proper maintenance and lubrication of the fan to maintain the position of both fans at the same level, so that both the fans can run at the same speed, same load and the optimal combined efficiency. So based on the some thumb rule or some experience after installation or after overhauling lubrications, so overall efficiency of that fan will be increased 15 to 20%. So by calculating this all, so total energy saved is this much kilowatt hour, and this is the amount saved per year is approximately 8 lakh, and the investment required is 20 lakh, which will be covered just in 30 months by implementations, our suggestions. Next is the reduction of pressure setting for service air system. So in industry, there are different types of compressors and are used for cooling and cleaning. So in plant, a huge quantity of service air is utilized as an air jet to cool bearing in coal mills, ID fans, and some other auxiliary, which is used for practice. So this is done due to inefficiency of heat exchanger. So hence it is suggested to put in service interconnection control valve in automobile. Yes, sir. Okay, sir. So this is the lighting efficiency studies. In this table, we can see the voltage level is more than 230 volts, and our desired voltage will 230 volts. So by reducing the voltage level at 230 volt, by reducing the lighting supply voltage to 230 volt, we can save the total amount is for daytime and night time is 1.54 lakh per year by just reducing the voltage from 250 volt to 230 volt, and there is no investment required for this. So these are the analysis of transformer. In transformer, we can see the load is very less, 14%, 18%, 30%. So the load calculated for above transformer is lower than the operating range. So for maximum efficiency, 25% to 55% load. But here the load is less than 25%. But looking at the reliable operation of the power plant, it is not advisable to switch off any of the transformer. And next is refrigeration and air conditioning system. So by doing calculations, we can save here also huge amount of energy by controlling the flow from 1.1 to 0.90. Here from table, which you can see the flow is 1.16 and 1.97, but desired flow should be 0.90. So by reducing such a flow, we can save huge amount of energy. And similarly, calculations for air handling plant. And here used two types of pumps. One is for HP and one is another is for LP. high pressure and low pressure. This is lightning load calculation. Again, we can reduce the voltage level from 237 to 54 and 244 to 230 volt. And by reducing this voltage on night time, and this is for daytime, we can say out amount per year is rupees 0.6 lakh without any investment. And from this table, we can say the amount of electrical energy consumption for different types of equipments in the plant. So finally, lastly, I would like to conclude. It is observed that the overall plant performance changes with the small variation in the output loads. From the calculations, it can be easily observed that huge amount of electrical energy is wasting. So looking at the varying load requirement, it is suggested to install different types of VFDs to control the speed of the CP in place of their control valve. Also, it is recommended to redesign the water cooling system for hot plant site by seeing worst water quality. Also, it is suggested to stop the air cooling where it is to reduce the load on compressor and to put in service interconnection control valve in auto mode. So according to load, it can be changed. So it is also suggested to set the tape position of transformer to reduce the supply voltage to 230 volt. And by implementing our suggestions, they will able to save approximately rupees 91 lakh per year, and total investment will be rupees 142 lakh, and the overall payback period will be just in 19 months. They can recover their investment amount. So after implementing the suggestions, the total annual energy saving potential will be 4.57 mega units, which is a huge amount of electrical energy. So these are the some references which I have used. Thank you. And if there is any question, then just ask to me.
Yeah, any question?
Madam, any comment? Madam Navita,
Yes, sir.
any comment? Because this is a report.
This is a case study.
Case study.
This is a case study, and this is a thermal power. This is a captive thermal power.
Okay, so based on the theme of our conference, what is sustainability part in this case study?
Sorry, ma'am.
As theme of our conference is sustainable development. So how this your case study is going or fulfilling the objective of sustainable development?
So I think we know that, ma'am, as the passage of time and by increasing the population, we see that there is a very lack of energy day by day by as the ratio of the increasing of population. So in industry, we can see that there are many major areas where we can save energy by implementing some new technologies, and by doing proper maintenance, they can save a huge amount of energy. And
what do you mean by captive power plant and cogeneration plant? Are they same or different?
Captive power plant, it means the industrial, it's a own power plant which is situated in their own campus.
And cogeneration?
So sorry, ma'am.
Cogeneration plant and captive power plants are same.
Cogeneration means, I think, the similarly generation of the waste of energy they can generate.
Yes, sir. The next presenter's name is Satan Namdev.
Thank you.
Hello, good afternoon, everyone. Am I audible?
Yes.
Yes, Satan, you are audible.
Present your.
Deepak sir, stop your
Good afternoon, everyone. I am Shashank Namdev. Here's my topic is about IoT-based transformer monitoring and control. Uh, so here's the index. We are talking about we will talk in this presentation. This is the abstract. As we know, uh, as my topic is IoT-based transformer monitoring system. In this, as we know, the transformer plays important role in power system. Any damages and faults in a transformer affects the balance of power system. The losses are mainly occurred due to mainly occurred due to overloading and improper cooling. Transformer health monitoring system help to overtake the equipment before failure and a continuity of power will not be disturbed. The main objective of monitoring the health of transformer condition using Internet of Things technology. The parameters such as current, voltage, temperature, and oil level of a transformer are monitoring, processed, and recorded in servers. For this purpose, we apply sensors interference with 8 328 microprocessor. The recorded data will be sent using Wi-Fi module and authorized person will access from anywhere around the world using IoT technology. This helps in identifying without dependency of human. This helps in identifying and solving problems before the failure without human monitoring. Here are some keywords. Okay. As the introduction, as we know, electricity plays an important role in our life. Every moment of life depends on upon electricity. Electricity have several components and equipments helping human to transfer and regulate the distribution according to usage. The crucial equipment of transmission and distribution of electrical power is transformer. In power system, electrical component transformer directly distributes power to low voltage users and its operation conditions is a criteria of entire network operation. The majority of devices has been serviced for many years in a different electrical, mechanical, and environmental conditions. They are mainly they are the main components and constitute the large portion of capital investments. Operation of distribution transformer under rated conditions as per specifications in their nameplate guarantees their long life. However, their life is significantly reduced if they are subjected to overload, overheating, or high voltage current, resulting in unexpected failure and loss of supply to large number of consumers. Thus is affecting system reliability. Overloading, over temperature, oil temperature, load, current, and ineffective cooling of transformers are the major cause of failures in transformer distribution transformers. So the main objective of this proposal is to acquire data of a transformer health remotely over the internet using IoT technology. We are going to monitor the transformer parameters such as temperature, current levels, oil levels, voltage, humidity. This data will be sent over using internet TCP/IP protocol. From there, we will able to read all the data in the world, anywhere from the in this world. For the real-time aspects, we take one temperature sensors, one potential transformer. If we are talking about PTR, one current transformer for monitoring temperature, voltages, and currents, data or transformer, and then send them to remote locations. Here's the block diagram. Here's a transformer and some sensors like voltage sensors, temperature sensor, current sensor, oil temperature, oil level sensor. There is a sonic sensor and frequency. Here's a microcontroller. We are using Arduino UNO in this system, and that will help to display the our parameters to the LED screens, LCD displays, and then microcontroller give the what we can say, the readings over LCD screen, and IoT module will send this to our phone or wherever we are sitting at using IoT technology. The components we are using here is LM35 temperature sensor, an LCD screen, a Wi-Fi module, a voltage sensor and a current sensor, and UNO, Arduino UNO microcontroller. So here is a working. Here we have a single phase transformer, AC supply single phase transformer with 50 Hz frequency and 230 volt voltage. Here is a bridge rectifier which converts the AC supply to DC supply for our this setup. And here's several sensors like temperature sensors, oil sensors, and quality sensors, oil quality sensors. This is Arduino Nano microcontroller, which is 14 pin, and here is a display screen, and in this will send the whole data to Wi-Fi module. If there any kind of failure or tripping is observed, the buzzer will active and send data to our GSM module, and it will show in our app. So here is the parameters here we need to monitor: transformer temperature, oil levels. As I saw in any irrigation field, oil are decreasing from the transformers and occur failures. Yes, sir.
Continue your research, Prashant.
Okay. The above study outcomes from hard difficulties of determining faults, obtaining causes in transformer, and its overcomes. That the problem of previous working method. The project focuses mainly on efficiency of monitoring process of transformer by wireless communications that deducted the use of large cables, which are too costly, low reliability, and much maintenance. The main reason of the project is to design and construct an IoT-based transformer monitoring system, which can display real-time states in transformer. All the examination of the devices, the system was tested successfully. That is, the device can monitor the condition of transformer and send the data accumulated from the sensors through Wi-Fi and displayed over the IoT platform. All the parameters that are critical and have make their threshold limit can be sent through SMS for fast actions can be taken. Here some advantages that increase system reliability and stability by monitoring system. Overcurrent, over temperature are prevented using this technique. And some applications are distribution, transformer monitoring, smart grid, and transformer monitoring. Here are some references. Thank you.
Is there any question? The next presenter's name is Prasansa Saxena. Prasansa. Is there any question? Okay. We will proceed. Prasansa Saxena is okay. Now I invite our chairperson for their knowledge with us.
Can I leave?
Okay.
Thank you, sir. Yes, sir.
Please start your presentation.
Sir, आप unmute. Mute.
Mp Gautam sir. Unmute yourself, sir.
Dr. Navita, would you like to comment on these present papers? Because this is your field.
Yes, Shashank, can you please tell me your proposed method can be applied to what rating of transformers?
Ma'am, it may be applied to distribution transformers and as well as potential transformers. I mean, ma'am, PTRs also, but it may take some costly sensors and equipments to.
What changes you need to make if we will apply your proposed methodology to HV transformer?
Yes, ma'am.
High voltage transformer. If we apply this methodology to HV transformer, what sensors you need to change?
I think we are already using all these things, but in a low technology for this time, and by researching by all these, I think from the period of time it may be ready to use this technology.
According to me, I think humidity sensor, temperature sensors will be same or it needs to be changed. Humidity sensors or temperature sensors, will be same for HV transformer or it will be same?
Yes, ma'am, it will be same for them also because they are sensing the temperature. The rating of the sensors will be more because of their high voltage itself. So I think it will be same.
Okay. Any isolation will be required for this?
Ma'am, yes,
any
ma'am.
isolation, because we are working on high voltage transformers, so any electrical isolation will be required or not?
Yes, ma'am. Isolation is required as we if any kind of fault occurs from the transformer or transmission line, the several part of the supply will be cut off by isolating, and on this we can't stop the whole network. So by isolating from the particular side, we can use the other sections to work. Okay. Thank you, ma'am.
Thank you, Shashank. Thank you, ma'am. Now, I invite our chairperson, Dr. Mp Gautam sir, to share their knowledge with us. In view of this, I request Dr. Mp Gautam sir to enrich us with your words of wisdom.
Okay. So I would, first of all, I would like to, all the presenters, they have very nicely presented with the new themes. I will give you some interesting papers. Those Parmeet Karmal discussed about the conventional and non-conventional energy resources of energy, like solar, hydro, bio, and thermal. Similarly, Ramakant discussed about the electrical meters, very interesting. And furthermore, Kuldeep Pandey designed the turbine for domestic purpose. So all the students, similarly others also, all the students have a specific vision. They are intended to do something, but within their facilities, they could do, it is a good thing. If somebody has the vision in the future, they can do much more better than the present. So once again, I would like to thank, especially I would like to thank Dr. Navita Khatri, because she is directly related to this subject. He has commented very nicely and made some queries with the students and motivated them. So I hope that these students will in future will do much more better than what they have done at present. And I could find that the conference which has an objective, it is fulfilling with their efforts. The students have taken the pains to prepare the paper. They have designed. There may be some limitations, however, because they are not in factories, they are in the colleges. They have their own limitations. But I am very much impressed that each and every student have done a good job, and I hope for their better future. Thank you very much.
Thank you, sir. Thank you, sir, for very informative view. I would like to call Jaya Sharma ma'am for vote of thanks.
मूड है जया तुम्हारा?
Thank you, sir. Thank you, sir. At last, it is my privilege to propose vote of thanks to all those who helped us in making this session a successful one. On behalf of my university and the entire management group here, I want to thank our chairperson, Dr. Mp Gautam sir and Dr. Navita Khatri ma'am, who gave their vital time from their busy schedule to grace this session and sharing their graceful words with us. It was a pleasure to have you with us. I would like to express my gratitude to all the presenters for giving up their time and providing their papers to this conference. And last but not the least, I would like to thank all the directors, HOIs, HODs, faculty and staff members of Sri Vaishnav Vidyapeeth Vishwavidyalaya for their direct and indirect support in the conduction of this event successfully. Many thanks to all of you. Once again, thank you so much. Have a great day. Jai Hind.
Thanks should also be given to Srikant for you have forgotten his name.
Thank you everybody for your valuable time.
Thank you, sir.
Okay, madam. Thank you.
Thank you.
Namaskar.